Welcome back, everyone. This is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects and Go Cloud Careers. And today we're going to continue with day 3 of the Go Cloud Careers completely free Cisco Certified Network Associate CCNA 200-301 training camp. And this is a completely free CCNA 200-301 course. My name is Michael Gibbs, and of course, I'm with Go Cloud Careers. So today is going to be day 3 of our CCNA program. And whether you desire to be a network administrator, a network engineer, a cloud architect, a solution architect, this Cisco Networking Essentials training, or network administrator training, or network engineer training, or networking for cloud computing training will help you go out there and get yourselves cloud hired. These are critical cloud architect skills. This is critical cloud architect career training. And this is some critical cloud career tips. Because guess what? If you're a cloud architect or desire to be a cloud architect, half of what the cloud is a network. The remaining 50% is a data center. And if you want to be a network engineer, like I started my career, it's a wonderful job. If you want to be a network architect, where I spent multiple decades, again, it's a really wonderful job. So again, this is free network training. Basically, we began with what is a computer network and started with this as an intro to networking course. As you can see, we get into networking and cloud computing as well. But let's have it. Let's begin. Let's have some fun. So if you're here and you're awake and you're alert and you're oriented and you want to have a good time and learn a lot of networking, type hashtag CCNA. And if I see that, I'll know you're awake, alert, oriented. And then I'll start getting into the content. Daniel Green, I love that. Where is Cindy? Cindy right now is unfortunately chasing some squirrels around in my backyard. So I feel very bad for the squirrels. I asked her not to do that, but she doesn't seem to listen to me. So she's not on my lap this 5 minutes. But thank you for asking. She's doing great. So realistically speaking, so good to see you. Georgetta, wonderful. Alexandros Kalispera, Daniel, Hike, good to see you. Earl, and CCNA, Mr. Gee, CCNA, I'm loving this. I can see that you're there. Nikhil's here, fantastic. Crypto, fantastic. Sarah, welcome back. Ned, welcome back. Sanchin, fantastic. Brian, wonderful. Muhammad, fantastic. CCNA, Ransom, CCNA. Elvis, CCNA. Sadie, CCNA. Ruth, CCNA. Daniel Green, CCNA. Leo Paredes, CCNA. Mick B, hello, Mike, Chris. Hello, Brew Renters, thank you so much. And Emmanuel, CCNA, fantastic. Angelo, CCNA. And Casigo, CCNA. Not sure how to pronounce that name, but thank you so much. And CCNA. And Jeannie, it's so good to see you today. Dan, CCNA, I get it. I'm loving this. Jim Weaver, CCNA, I'm fantastic. Sharon, good to see you. So good to see you. CCNA. Mark Hema, CCNA. And Udi Wilson, so nice to meet you. Farman, so nice to see you. CCNA. Jabuki, CCNA. Hasnat, CCNA. Fantastic. So let's have some fun and talk about some networking training. Now, some stuff in networking is really fun. Some stuff is a little dry, but it's all necessary, whether you want to be that cloud architect, solutions architect, or network engineer. So having some fun with this, let's start with subnetting. Subnetting. And let's talk about subnetting. So when we're dealing with IP networks, what we're really dealing with is being able to make sure that our traffic can go from place to place. And realistically speaking, in order to do that, every interface on our network needs an IP address. Say it with me. Every interface in our network needs to be on a different network or subnet. So you've got a router with 4 interfaces. They're going to be on 4 subnets. You got a server with 4 network interface cards. Guess what? They're going to be on 4 subnets. You got a firewall. Each port on it, chances are, is going to be a different subnet. Is going to be on a different subnet. So that's what we're talking about. Is everything needs a different subnet. Now the reality is, if we're not careful, we could waste so many IP addresses, so many of them, that what it could do is it could, literally speaking, use up pretty much everything that we actually have, all in a couple of interfaces. So, when we're dealing with this, we're going to talk very carefully about why we have to subnet. So I'm going to give you a couple of examples, and I want to show you why we have to subnet. And we're going to get into a lot more depth of the rationale of why, but let's just walk you through in a simple example. So in this example, what I'm going to show you over here is I'm going to show you a network that's not been subnetted. And for example, here we go. I've got a network here. I've got 4 interfaces on a router, and we'll talk about what we mean by class A, class B, class C, class D addresses, site or routing, and all this cool fun stuff. But if I didn't subnet a network and I used this 2.0.0/8 as a subnet on one port, and the 1.0.0/8 as a subnet on another port, and I used the 4.0.0/8 on another port, and the 3.0.0/8 on the subnet. Wow, do you know how many IP addresses I would use? 64 million. You heard me. I'd be wasting over 64 million IP addresses. Now, I did tell you can put up to 250 hosts in a subnet, 500 if we're really pushing it. So now we've got 500 on each port. Now we've got 2,000 hosts, but we've wasted 64 million IP addresses. Not so good, huh? So now let's say we were to break these networks down, and I'll be walking through this, but now we broke them down into something called the /30. A /30 is a subnet that has 2 available hosts. Now, on the same router, it's got WAN links. One link to another router, one link to another router, one link to an upstream router, one link to a downstream router. And we've subnetted down, and we're using a /30 subnet. I burned 16 total addresses. Now, I only used 8 of them, and I'm still wasting 50%, but I only used 16 addresses versus 16 million. So we don't have a lot of IP addresses. Do you want to waste 16 million of anything? Of course not. Of course not. So keep that in the back of your mind. So when it comes to networking, I'm going to tell you right now, your IP addressing plan or your subnetting plan is the most critical thing you have in your systems. Your IP addressing plan or your subnetting plan. Absolutely critical. So let's talk about and walk through some examples. And you'll see what I mean. So let's say here, we've got a switch, which is on one subnet. See this link on this router? This is all going to be on the same subnet. Now this is going to be in a different subnet. This is also going to be a different subnet. This is a different subnet, and this is a different subnet. So just in this example, we have a minimum of 1 subnet, 2 subnets, 3 subnets, 4 subnets, 5 subnets. Minimum. So what we have to do as network engineers, network architects, cloud engineers, etc., when we're dealing with networking, we have to think about what these things are. So, for example, if we made each one of these a /24, we'll talk about what that means. We'd have 250 hosts or 253 hosts available on the subnet. So good. 254. But anyway, so on this one, what do we need? If we use a /24, we're going to burn 260 or 250 some addresses. But if we use a /30, we only use 2. How many addresses do we need on a link that connects one router to another router? 2. How many addresses do we need in this LAN subnet? I don't know. Do we need 16? Do we need 32? Do we need 64? Do we need 128? Do we need 512? How do I know? Ask the customer. Hey, what do you want to put in here? I don't know. How many hosts? Determine my subnet. How many subnets I need? Determine my subnet size. So there's going to be some noodle work here. This is where we're going to get our hats on with the propellers on them. We're going to get a little geeky, and it's going to be fun. But, keep that in the back of your mind. So that's why we have to subnet it down. And we have to be very, very, very careful how we do it, because the addressing that we use will determine our routing. So the first thing we're going to do is we're going to analyze the needs. Number of subnets, number of hosts per subnet, and the size of the subnet will determine. Then we're going to design our subnets. We're going to choose the network. We'll pick our subnet masks. And then obviously we've got an implementation plan of typically speaking, it's the junior implementation engineers that go and configure this stuff. So that's kind of works. And we'll talk about how to do all of that. So let's analyze subnetting addressing needs. So how many hosts need to be able to talk to each other? There you go. How many hosts? And if you want them in a subnet, if you want them to talk to each other without a router, they have to be in the same subnet. So you might create two subnets for security, but you might want two people to talk to each other in the same subnet. It's most practical. So how many hosts? How many but that's you're going to need in the network. Remember, if you've got 10,000 WAN links, you're going to need 10,000 subnets just for your WAN links. Now, then we have to think about how many hosts do we need in that subnet. On a point-to-point link, which is effectively a wire between two people. Here's a wire. How many people? There's one person on the wire, one router, and one on the other end of the wire. It's a wire. How many addresses do we need? 2. That's it. Because there's nobody else we want on the wire. By using 2 and not 24, it makes it more secure. If people tried to get in there, they couldn't even get an IP address. They wouldn't be on the same subnet. So keep that in the back of your mind. So let's walk through another example. Need a subnet here, a subnet here, and a subnet here. Now, I'm going to give you some generic guidelines that are going to work in 90% of the situations. We use a /30 on a WAN because we only need 2 links. And you know what we use on a LAN? A /24, 255, 255, 2550. Now, we're going to talk through all the numbers, but you want to know what to do in practicality? /30 on a WAN link, /24 on a LAN link, and Bob's your uncle. Everything works great. But we'll get more specific because there's times we want to go more than that. Let's look at another example. Here, LAN segment, 1 subnet, WAN subnet, 1 subnet, WAN subnet, 1 subnet, WAN subnet, 1 subnet, and another subnet per LAN interface. So 1 subnet, 2 subnets, 3 subnets, 4 subnets, 5 subnets, 6 subnets, 7 subnets. Now imagine if we use the /8, which we'll talk about later, where we get 16 million addresses. So 16 million times 8. Wow. 64 times 2. We'd be burning 128 million addresses. We know you can't get more than 250 to 500 hosts on a subnet before we have too much broadcast traffic, so that'd be a waste. Let's look at a different version of this. Okay, we've got 12 VLANs over here. So how many VLANs do we need? Subnets for VLAN. Each VLAN's on a different subnet. So we need 12 subnets over here. We need a subnet for the WAN link. We need a subnet for the WAN link. We need a subnet. So now we're up to 15 subnets. Now we've got 2 VLANs here. So 17 subnets, 19 subnets, 21 subnets. Now imagine using 8 million hosts for that number of subnets. I mean, 16 million hosts per subnet. We'd be in the 40 million range of IP addresses that we're using, when the reality is we probably need 500, 500, 500. So that's 1,500, and 12 times and 12 times 250. Again, 250 times about 3,000. So 3,500 addresses effectively versus 40 million. Big difference. Let's walk through another example. Here we got it. We've got a core router, which has got a subnet to connect to this subnet. It's got a subnet to connect here and a subnet to connect here. So 1 subnet, 2 subnets, 3, 4, 5, 6, 7. Now, notice what they said here. They said the biggest subnet we have is going to have only 50 hosts per subnet. So if we wanted, it would be real easy for us just to do this. To pick a subnet that can handle, say, 50 users, to pick one that can do 16, another one that can do 32, or whatever the subnet size is. Now, and that's, perfectly using address space. Why do I recommend /24 for LAN links, /30 for WANs? See, in this particular environment where you say largest 50 hosts per subnet, yeah, we plan on 50 hosts per subnet. And you know what happens? The company does well. And they thought they needed 50 web servers in the subnet. And the reality is they need 100 web servers in the subnet, or 200 web servers in the subnet. And that's the thing. Because of that, I'm going to tell you, in your career, use a /24 for LAN links, no smaller, regardless of whether you can do the math. Use a /30 for LAN links. But we're going to go through the math here. Anyway. Now, when we're dealing with subnets, what we're dealing with is as follows. We got a 32-bit address with IP. 32 bits. So what that means is we have 2 to the 32nd in terms of the number of addresses. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, etc., etc. So 2 to the 32, which gives us a couple billion addresses, which is great, right? Okay. How many billion people in the world? 7 billion. Got a problem. How many mobile phones in the world? Probably 5 billion. How many computers in the world? Probably another 5 billion. How many smart refrigerators, smart homes, et cetera, that are out there? Billions and billions more. Internet of Things sensors out there. So does anybody see a problem? We ran out of IP addresses a long time ago. So that's why we have to be really careful. So what we're doing is we've got this 32-bit address, and it can be all network bits or all host bits. And what we can do is we can move the network bits over in one direction to basically make smaller subnets, or we can move the host bits to create bigger networks. And we're going to be doing a lot of that. So here's the reality. If this, it says need 200. So like I said, use a /24, that'll give you 254 addresses. Now, you need here 50, but if you use a /24, guess what? You're still going to be good to grow for growth, good to go for growth, good to go for growth. But would you use a /30 on this WAN link? I mean, a /24? No. Why not? We don't need 254 addresses on the WAN link. And even though I'm telling you to plan for extra in your LAN segments, guess what? Can we ever have more than 2 people on a WAN, on a point-to-point connection? If I'm looking at the Blue Ranch, if I want to run a wire between my house and Eva Doike's house, is that wire ever going to talk to more than 2 people? No, because it's going straight from my house to Eva Doike's house. So I only need 2 addresses. So there's no point to allocate room there. But for your LANs, give yourself room for growth. Now, in this particular case, and we'll work through examples like this, we're going to use more mathematical numbers. We're going to say, okay, we need a class C or a /24 here. We're going to say we only need 2 addresses here. And now we're being digital. We need 50 addresses per subnet, but there's no subnet that gives us 50. So what we do is we use a subnet that's got 64 total addresses. We minus out the network address. We pull out the broadcast, and now I've got a subnet that can support 62. And we create 3 of these subnets. And actually, we can create 3 of these all on a single class C address or a /24. So let's play around with this a little bit. Here we've got 4 class Cs or 4 /24s, which people like me in the networking world would call us a class C because, well, we'll talk about class A, B, and C addresses. Typically, those of us that have been around for a while, a /24 is a class C, a /16 is a class B, and a /8 is an A. We networking people have made up our own classes, which are totally different than the rest. So just so you know what that is. But look, as you can see, and this is generally speaking best practice, you've got a /30 for 2 usable addresses over here. And we've got what we're talking about over here is /24s for our LAN segments. So again, what are we doing? We're analyzing needs. How many hosts can be on each side of the link versus, realistically speaking, how many networks do we need? And that's realistically how we're going to do everything. So the next thing that I want to show you is for communication to occur, every device needs to have a unique address. So let's pretend it was mail. I want to send a letter to Eva Doike out there. I need her address. Now, let's say Eva Doike lives at 123 Greek Street in Hungary with a certain postal code. And let's say Mike lives at 123 Greek Street, but in Palm Beach Gardens, Florida, with a postal code of 349 or 53. My address is unique. Eva Doike's address is unique because our postal codes are different. Even if we both live at 123 Greek Street, because I speak Greek in the house and my family's from Greece, I kind of like using Greek Street, but whatever the case is. So when company A speaks to company B, they have to be on different addresses. So anything that needs to be reachable from the internet needs to have public addresses. And anytime one company needs to talk to another company, guess what? Again, we're in the same position where we need to have unique addresses. So we'll be talking about things like NAT throughout the thing in order to translate public addresses to private addresses, but that's coming in the future, not right now. Now, what I do want us to talk about is private addresses. And what happened was the Internet Engineering Task Force looked and said, we have an IP address problem. We don't have enough addresses. So if we want more addresses, what can we do? So what the Internet Engineering Task Force decided to say was they carved out a lot of addresses, and they said, all organizations use these internal to your network. Anything that does not need to be reachable by the internet or reachable by external entities, use these private addresses. And by organizations using these private addresses, we never ran out of address space. So, I mean, the point was is we didn't have enough IP addresses 20 years ago. Even 20 years ago, we were using these private IP addresses, and that enables us to kind of get a lot more mileage out of our network. So where do these private IP networks sit? They are the 10.0.0.0/8 subnet, which is as a class A, which we'll talk about later. But it is 2 to the 24th number of hosts that you can put in there. Wow, that's a lot. 2 to the 24th is about 16 million to put in your mind. Next, the Internet Engineering Task Force said, we will use the 172.16.0.0 all the way to the 172.31.0.0. So it's the 172.16.0.0/12 address base. And guess what? That gave us basically 15 or 16 class Bs we could use. So by doing that, we've got a lot of addresses per region, and we split it out. Again, lots of usable addresses. Next, we decided to dedicate the 192.168.0.0 all the way to the 192.168.255.255. Guess what? What does that give us? I'll tell you what it gives us. It gives us 2 to the 16th in terms of number of addresses. So lots of addresses, lots of networks, all kinds of cool stuff. So that's what we did. And those are the addresses we're going to use inside of our networks. Now, if it's in our network, great. If it's in the AWS cloud, great. If it's in the Azure cloud, great. If it's in the Oracle or the Google cloud, great. It's the same thing. A cloud is nothing more than a network and a data center that's been virtualized. So let's look at the system of format of unsubnetted class A, B, and C networks. The number of networks of a class A is 8 of them, but we've got 24 host bits. So how many hosts per segment? 2 to the 24th minus 2. Why? 24 bits of host, 8 bits of network. So 2 to the 24th minus 2. Anybody wants to do the math? You'll see that it'll give you basically 16,777,214 addresses. That's a lot. Remember, we can only put about 250 in a subnet before we waste them all due to broadcast. So that's what we're doing. So now the class B that I was talking about, the /16. Well, 2 to the 16th minus 2 is about 65,000 addresses, 534. Again, a whole lot. You're going to be subnetting that down. Class C, number of network bits is 24. Number of host bits is 8. 2 to the 8th minus 2. And guess what? That's why you get 254. So why is everything 2 to the whatever? We're dealing with the binary address. What is binary? 0 and 1. How many is that? 0 counts as a number, and 1, that's 2. So that's why we're dealing with 2 to the x minus 2. Now we're going to subtract 2. So why are we subtracting 2? So the first address is going to be reserved by the network. So 192.168.1.0, 255.255.255.0, otherwise known in CIDR notation as /24. I can't use the address of 192.168.1.0. Why? That is the network address or the subnet address. That's what the routers are going to put on the routing table to build them out. But they can't use that address. Now, 192.168.1.255, that's called the subnet directed broadcast. And what's that mean? Everybody listen to me, everybody listen to me, everybody listening to me. So we can't use that either because that's a screaming loud broadcast. So with every subnet, it's going to be 2 to the X number of host bits minus 2 /30, 2 to the 2, which is 4 minus 2, /29, 2 to the third power minus 2. 8 minus 2 is 6. 2 to the fourth, 16 minus 2. Guess what? 14. So now you get it. Broadcast address. So that's really what we're talking about. And what's it going to look like? It's going to look like this. And I'll show you. So A, you've got 8 network bits and 24 host bits. Class B, you got 16 network bits and 16 host bits. Class C, we got our 24 network bits and our 8 bits of host bits. So you can see what we're dealing with here. So now let's decide to subnet it down. Instead of dealing with that class A, we used to be using the class A, it was a /8. Now, guess what? Instead of keeping it as we could have 10.0.0/8. Or, and what can we manipulate there? The 10 is going to be there. We can do the 10.1 all the way to 255 effectively. And on the third octet, we can do the 1 to 255, or 0 technically. And on the third octet, we could go 1 all the way to 255. So that will be 2 to the 24th minus 2. But now, let's say we want to subnet this down. Subnet it down. We're going to subnet it down. So we're going to get 8 subnet bits plus 8 host bits. So now, instead of being 2 to the 8 minus 2, now it's 2 to the 16th minus 2. Wow, 65,000 addresses versus 16 million. Let's subnet it down some more. Let's subnet it down to 255.255.255.252. Okay, how many network bits? 30. How many host bits? 2. And that's all we're doing with the subnetting is sliding in one direction back and forth to either or. That's all it is. So if we need a certain number of subnets, we borrow host bits and go this direction. We need a certain number of host pair subnets, we go in this direction. And vice versa till we have our subnet size. That's what we're really talking about. So when it comes down to it, it's kind of like the power of 2s. Because binary is a 32-bit address. It's either on or off. Now, this gets a little complicated for Americans, and it's much easier for Europeans because in Europe, when we push the elevator and we go to the first floor, it has a 0 on it. And then the next floor has a 1 on it. So Europeans count starting at 0. Now, Americans start counting at 1. So when you tell an American floor number 1 and they're in England, they think they're on the first floor when they're really on the second floor, and it causes all kinds of confusion. So that's why if you're not used to starting at 0 and counting 0 as a whole integer or a whole number, then you will find this confusing. So just remember, we start at 0 or 1. Binary addresses are 0 or 1. And we'll have some time. If this gets complicated, I have some other slides that I created that are a little less like the Cisco slides, which we can use. Because no matter what, you will all understand subnetting by the time we're done this. So let's do a little bit of analysis. Here in this particular environment, we figured out that we were going to use this subnet. And by using this subnet, we need, realistically speaking, 200 hosts per subnet. So in this particular case, if we need 2, we do a /8. We need 200. What do? We have to find the thing that's next closest. So is there a subnet that gives us 200? No. Is there a subnet that gives us 256 minus 2, which is 254? Yes. That is a /24. So that's what we use here. And we'll walk through the math. I have a couple of charts should people not be enjoying this, and I'm going to start with one right now. Here is what this looks like binary-wise. we've got all ones and all ones. For the extra subnetting, we've got all ones. For the host, we've got all zeros. So what I like you to all do is look at this chart. We're gonna to make it consistent. Everything we're gonna do over here is gonna be as follows. I want you to think about. Let's just bring this over here. Everything we're going to talk about is bits and bytes. So 128, 64, 32, 16, 8, 4, 2, 1. So let's look at it this way. We've got, actually, I think I'm going to introduce this a little bit later. I might be too premature for us to do this. So now let's go walk around and play with some additional subnets. If we look at this, these are our usable addresses. So 172.16.0.0, what does that enable us to do? It enables us to use this for the router. This is that, hey, everybody, broadcast. And these are our usable addresses. So again, in another situation, we go to the next subnet. These are the address range that we can use. This is, again, that everybody broadcast. So I hope that kind of makes some of this relatively simple for you. And we're going to get through the numbers and how to do this. But before we actually get to the numbers, let's look at this. And this is a good thing for you to really get. What we're trying to do is as follows. We're trying to make sure that when we design our systems, we've got a subnet range for one set of systems in one geography, a subnet range for a set of systems in another geography, and another set of subnet range for another one. Because what we're trying to do is minimize the routes that we need to actually send to somebody. So for example, we can have one route that we can send over here that summarizes all of this. We can have another route for this entire summary address, and we can have another route over here. So this is pretty beautiful. Why is it beautiful? They've chosen dissimilar information for each section of the network, and that's what we're going to want to do. We're going to want to segment it out. So let's work through this little example here. Let's say we got a server over here, and its server has an IP address of 172.16.1.11. Now, that server is on the 172.16.1.0 subnet. That's what the router sees in its routing table, and it tells the rest of the world. Okay. Woohoo. So now, how many addresses do we need on this link? 2. How many addresses on this link do we need? 2. So this PC over here is going to have a default gateway. And for example, if this PC wants to go to this PC, the PC needs to have a route in its routing table. And guess what? Most PCs don't have a lot of routes. What did the PC have? This is my default gateway. So let's say this PC wants to reach this, or this server wants to reach this PC, what have you. Server goes to the default gateway. The default gateway says, I know how to reach this system. Send it this way. This system says, I know how to reach it. It's my directly connected LAN. ARP, who has the MAC address? This guy responds. This guy responds, and he says, I don't know where to go. I got a default gateway. The default gateway says, yes, I'll give you that MAC address. Now the router forwards the thing to this next thing. Now the router forwards to the server, and she says, I'm here. I responded. The server basically responds to the message. The server looks in its routing table, goes to its default route, and that's how messages are passed back and forth. That's how messages are passed back and forth. So we're going to actually start getting into some of the math of subnetting pretty quickly. And, some of that's going to be fun. But before we do that, I want to make sure that we've given you guys some, we've had a chance to go through some questions, because we've been babbling for about an hour and, or at least about 35 minutes. And, some of this stuff gets relatively complicated fairly quickly. So let's take some questions. Chris, it looks like there's some stuff in there. If you want to come and bring some of the questions onto the StreamYard screen. Hey, Mike, can I please guide when you use Class B versus Class C? Raul, here's the thing. There is no such thing as a class A, B, or C address anymore. What you really is, you're going to use a /30 on WAN links, and you're going to use a /24 on a LAN link. And pretty much that's what you're always going to use for everything. We can never use a class B. We're going to have to subnet it down because we'd be wasting 60,000 addresses. So class C /24 for LAN links, /30 for WAN links, and that's going to work in 90% of your environments. Chris, you want to bring in the next one? Default gateway is a default route. That's all it is. A router is often called a gateway. So on PCs, they call it a default gateway. If you put a default router on a router, they call it a default route. Same thing. Good question.
And Mike, can you go over the last diagram again? For some reason, your cursor wasn't showing up on the screen, so people couldn't see where you were pointing when you were talking on the last one.
Yeah, I don't know which was the last diagram I was on, though. I don't know which was the last diagram I was on, Chris.
Okay.
Crypto Fiend, you got a bunch of acronyms, and I don't really understand what you mean by VXLN. Tell me in some plain, simple language, and I'd be happy to understand it for you. Chris, do you want to bring in the next one? One thing I will tell you, if you're in engineering, you ever desire to be architects, don't ever use acronyms. Your customer won't know. In medicine, they teach us not to use acronyms for the following reason. I can give you 50 different definitions of a VLAN. And now that you've got another one, it becomes totally impossible to figure out where it's coming from. So just spell it out exactly, and we know what you want. Williams. Okay, that is good, Williams. You're already ahead of us. So the reality is what you're going to see is in the old days, we had class A's with a /8 and a class B with a /16 and a class C with a /24. And guess what? About 25 years ago, we went to classless interdomain routing. And by doing that, we basically moved that thing around. And the whole point of using a class B address with a class C subnet mask is subnetting. That's exactly what we're doing. And yes, we intentionally are doing that. Absolutely. And if we don't, we'll be burning 65,000 addresses every time we use a class C on a single interface. So yes, it matters, and we no longer use any kind of classful addresses. Everything's classless at this point. Good, solid question.
All right, so people are responding about which slide it was. It was a static from the low end and DHCP from the high end slide.
I don't know which slide that is. Why don't we go to a question that I can actually answer?
Okay. I'll wait for some more questions to come in.
Let's answer some questions I can answer. I don't know what the slide is. I'm skipping around through a 2,000 slide presentation. There's no way I can get to it. But I can actually answer technical questions or networking questions that aren't related to a slide. I don't know, Mohammed. I haven't worked with VLAN extensible local area networks. Yes, we'll be talking about CIDR or classless interdomain routing. Absolutely. /24, /23. That's the subnetting we're going to get to. How is the subnetting the same or different? It's almost the same whether you're subnetting a 32-bit binary versus a 128-bit hexadecimal address. It's pretty much the same. Okay, Chris, you can bring in the next one.
There's not any more questions.
Oh, okay. Well, then we can get back to the content. So let me make sure I may do this a little differently on the subnetting piece. Bear with me a second. Okay, so let's talk a little bit more about subnetting. And here's where we're going to talk about how to actually do it. We're going to begin by talking about this concept of the Class A, Class B, Class C. Now, previously I mentioned and I gave you the Class A addresses. And a Class A was anything that began with a 1 all the way to a 126, and it had a /A subnet mask. And then I told you there was a Class B, which had a /16 subnet mask, which was basically 128 all the way to 191. And that was a Class B. And then I told you we had a Class C, which was basically the 192 all the way to the 223 /8. But guess what? They don't exist anymore. We don't use them. They were the address classes. And because of that, we said, wait, I can't use a /8 because if I use a /8, I'm going to burn 16.5 million addresses on a subnet. So about 30 years ago, when we came up with the concept of subnetting, we said, we can't use IP address classes anymore. They're dead. So what did we come up with? We came up with classless interdomain routing, which basically meant we would subnet our class A's, B's, and C's, and then they would no longer have those silly /8, /16, or /24 masks. So classless interdomain routing really means subnetting. That's it. That's it. So no such thing as a class A address, B address, or C address. They don't exist anymore. They did 40 years ago. About 25, 30 years ago, we went away from it. So keep that in the back of your mind. Now, this was the default mask. So we don't use the default mask. So let's go back to this picture again. With a class A, it was 8 bits of network and 24 bits of host. So 2 to the 24th minus 2. 16,777,000 addresses. Again, you can't put more than 250 on a subnet. Maybe 500 worst case scenario. Where you get broadcast. So kind of keep that in the back of your mind. So what we did here is as follows. We took a /8 and we subnet it down because otherwise we'll have 2 to the 24th minus 2. We can't use that. Or this class B. Now, it was cool when in 1980 somebody thought of the idea of a class A, class B, and C. And when the internet was designed and had 50 users on it, it was cool. But look at everything that has an IP address. So clearly this isn't working. So we decided to subnet it down. How do we subnet it down? We added more bits of network. So the class B, which used to have a /16, can now have a /29, a /28, a /27, whatever we need it to be to give us the number of hosts and networks that we need. That class C was a /24, but guess what? And we'll do some labs with this today. We won't use a /24 on a WAN link. Why? We don't want to burn 254 addresses when we only need 2. So to get to our goal, we got to get smart. How do we get to our goal to get smart? What do? We do the math ourselves. So this is what a class C looks like. All of our, we've got 8-bit mask bits, another 8 more because it was a class B. Now we added 8 bits of subnets. Now we have 8 bits of hosts. So 2 to the 8th minus 2. Before, we had 2 to the 16th. So 2 to the 16th, 65,000 and change, minus 2, still 65,000 and change. Now, we can only put 2 on a WAN link and about 500 on a LAN link. So is it a good idea It depends on the link. If this is a LAN link, guess what? Awesome. Perfect. If this is a WAN link, not a good idea because we're wasting addresses. So let's look at it a different way. I want you to see CIDR notation, binary notation, decimal notation. So I speak in CIDR notation, /24, /25, /30. Why? Because when I communicate to a networking person on the end of the phone, and I say this is a /30, they know what that means. In medicine, when I tell another doctor the patient has a macular papular rash, they're instantly thinking of scabies on the other end of the phone call because they know what a macular papular rash is. So we use CIDR notation and CIDR communication because everybody knows what it means in networking. So /24, /30, etc. Now, this notation really is just a number of bits. So look at it this way. Here is your class C. All ones in the network, all ones in the network, all ones in the network, 255, 255, 2550, or /24. Now, let's say we want to take this and chop it down a little bit. We're going to go 8 bits of network, 8 bits of network, 8 bits of network. Oh, wait, an extra bit of network over here, which means now for hosts, we have 2 to the 7th minus 2. Now let's go over here. 8 bits of network, 8 bits of network, 8 bits of network. Oh, wait, 2 more. 8 plus 8 plus 8 equals 24 plus 2 equals 26. Okay. 255, 255, 255, 192. So I'm going to show you where these wacky numbers are coming from in a minute. Now, here we go. We're going to do a /27 now. So 255, 255, 255, 224. Wow. Where is this coming from? 24 bits, right? 8 plus 8 plus 8 plus 3. Now it's 11. So what are my hosts? I have 2 to the 5th minus 2. 2, 4, 8, 6. Oh, hold on. 2, 4, 8, 16, 32 minus 2, 30. Okay. Now, break it down one more. Now we've got 8, 16, 24 plus 4, 28. 2 to the 4th minus 2. 2 to the 4th minus 2. 2, 4, 8, 16. Guess what? Map out 2, we've got 14. No, caveat, 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 warning, 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 warning. If you're on AWS or some of the other cloud providers, they have a funny take on IP networking. They decided not to read the documentation of the Internet Engineering Task Force and make up their own. So when you're dealing with AWS, they get rid of the first 4 addresses and the last address. So in normal networking, the first address is lost due to the network. The last address is lost due to the broadcast. But if you're working with Amazon, they reserve the first 4 addresses and the last one. So go back to the /28. 2 to the 4th minus 5 on Amazon. So 2, 4, 8, 16 minus 5 is 11. So 14 addresses in every network in the world except for the cloud providers, and you may only have 11 there. Why am I telling you this? Because if you're on a cloud provider and you use a /28 and your devices are going to scale, you're going to run out of IP addresses pretty quickly because you don't have enough. So make sure you don't run out of addresses. And I recommend for the LAN in most cases, /24, 255, 255, 255.0. Now let's talk about some special other subnets. /29. Well, let's look at this. 24 bits plus 5. That equals 29. That's how we got to the /29. 255, 255, 255 /248. Okay, how many addresses here? 2 to the 3rd, 248 minus 2, so 6 addresses. Now let's look at the /30. The /30 is every networking professional's favorite one because every point-to-point link gets a /30. So let's look at this. 8, 16, 24 plus 6. The mask looks like this. 255, 255, 255, 252. Okay, that gives us 2 host bits. 2 to the 2. 2 times 2 minus 2 gives us 2 usable addresses. Wow. One address on both sides of the wire, the perfect subnet for a WAN link. So what does everybody use in the WAN? They use a /30. So keep that in the back of your mind, and I'm going to show you where this numbers come from in a minute. So let's look at the next one, /31. 31 bits of network mask. Now let's think about this. 2 times 2, or 2, because there's no exponent here, minus 2 equals 0. So not a usable subnet. Which gets us into this really wacky subnet called the /32. What a /32 looks like is all ones. No. Now, you can actually, on a router, create a loopback. We can create this is called a host root or a host subnet. And there's a very wacky thing. We use this for administration purposes in cloud computing. So where's all these numbers and calculations coming from? Let's play with it. Look at it this way. 128, 64, 32, 16, 8, 4, 2, 1. So think about it this way. 1, 1, 1, 1. 128 plus 64 plus 32 plus 16. 128 plus 64 plus 32 plus 16. Somebody add it up to me. And now you know what that mask is going to be. So we're going to do a couple things. We're going to calculate where the subnet begins, and we're going to look at this. So everybody right now, I want you to tell me in terms, what is a slash? Before I even ask you to do this, let's do this. So let's work through this one together. So what do we think this subnet mask looks like for this /25? Let's build it in right now. What do we have? We have the subnet mask is a /25. So 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 1, 2, 3, 4, 5, 6, 7. So now look at this. Okay, what do we think the /subnet mask is going to be? I think I saw it from Aguilo or Angelo, depending on whether you're from Italy or Greece. He figured it out. It's going to look like 255, 255, 255.128. Okay, let's look at the next subnet. Let's look at this /27, the 172.16.127. So let's add 2 more bits, ... So let's figure out what this mask looks like. 128 plus 64 is 192 plus 32. Do the Jeopardy music while you guys answer it. Do 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 do. Okay, what's this mask look like? Okay, 128 plus 64 plus 32. Somebody tell me the mask in the chat box. I even played the Jeopardy music for it, which is humiliating, but I wanted to have fun and just enjoy it. So let's say, what's this going to look like? 128 plus 64. Angelo, 224, fantastic. Sarah Ahmed, 224, fantastic. I'm loving it. See, you guys are getting it. Nitropan, excellent. Earl Owens, excellent, excellent, excellent stuff. This makes me happy. John Clark, 7 Series Beamer, excellent. Nitropan, I'm not really sure what you got there, but we'll work with it. You got it right the first time, Nitropan. So, Dan DTM, fantastic. Okay, excellent. Excellent. Now, let's take this one. Let's take the 172.16 1.27/32. What's that goofy mask look like? And this is going to be a cuckoo mask now. We'll add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. I wonder what that would be. Let me go out there and get my calculator. If I can't figure this out in my head, let me get my calculator out there. We're going to do a 128 plus a 64 plus a 32 plus good answering it, a 16 plus an 8 plus a 4 plus a 2 plus a 1. Exactly, everyone. We got 255. How did I know it was 255? Because we know that this is always 255, but I wanted you to figure it out. All right, you guys are doing great. Now let's do this /28. You guys are making me happy. I'm proud of you guys. You're doing fantastic. What /28? It's going to be a 128 plus a 64 plus a 32 plus a 16. Bring the Jeopardy music back. Do 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 do. Okay, Ruth, you got it. I'm so happy. Earl, you got it. Fantastic. Alexandra, Polikala, Imapolia Feristimanos. And I hope you know what I mean by that, Alexandra. But fantastic. I'm seeing it coming from everywhere. I'm loving this. We're going to go through a few more examples because I don't want anybody doing my free networking training and not be smart, capable, and hireable when they're done. So we're going to go through a few more because I want you to be great. Very happy that you got that, Alexander. Fantastic. So now let's play with this /29, everybody. /29. What is that? 1, 2, 3, 4, 5. Okay, 128 plus 64 plus 32 plus 16 plus 8. Jeopardy music. Do 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 do. Wow, we got it. Angelo got it. MJ's got it. I'm loving it. Ruth's got it. Earl's got it. Wow, we're doing good. Okay, fantastic. You guys got it. Now we're going to do one more. We're going to do the /30, which means 1, 2, 3, 4, 5, 6. Jeopardy music. Do 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 do. Okay, I'm waiting for this to come in. Ruth, you got it. 252. Earl, you got it. Alexandros Polikala. Fantastic. Chibuki, you got it. Sarah Ahmed, you got it. Mark, well, not sure. LM, I got it. Eric Strotz, I loving it. 7 Series Beamer and Lavone. Fantastic. You guys are doing wonderful. I am so happy and proud of you right now. So now, here's where we get a little bit of trickiness. Now, sometimes on a networking interview, they ask you where the subnet begins. Where does the subnet begin and where does the subnet end? So let's talk about that. When you look at a subnet, I'd like you to be able to remember this 128, 64, 32, 16, 8, 4, 2, 1. Keep it in your mind. Remember this. And if you don't know, you can always draw it out. 128, 64, 32, 16, 8, 4, 2, 1. Write it out. Now, when we have a /25, we have 2 subnets. We have the 192.168.1.0 subnet. And the next subnet we have is the 192.168.1.128 subnet. 2 subnets because we have 1 bit of subnet. So it's 2. So when you're on networking, if you're on the router looking at the routing table, or if you have a task as part of your cloud architect, solution architect, or network engineer, network administrator, or network architect exam, they're going to say, where does the subnet start? Where does the subnet start? So if they were to say that, here's the secret. 192.168.1.132. Is this number divisible by this with a number of greater than 1? Yes. Is it divisible with less than a number greater than 2? No. So I know that this subnet begins at 192.168.1.128. I also know this subnet ends by adding 127 plus that, which means it begins at 192. It ends at 192.168.1.255. Now let's go back to this one. It's a /27. So I have to look at this and say, what is divisible by what? So is 27 divisible by 128 with a whole number? No. Is 27 divisible by 64 with a whole number? No. Is 27 divisible by 32 with a whole number? No. Is 27 divisible by 16 with a number of greater than 1 and less than 2? Yes. So now we're going to go here. Where does the subnet begin? I can tell you right now. Take the first subnet goes 172.16.1.0 and it ends at 172.16.1.31. The next it ends at .15. So first subnet begins at 172.16.1.0 and ends at 172.16.1.15. Next subnet begins at 172.16.1.16 and it ends at 172.16.1.31. Which subnet does this belong to? The .0 or the .16? Pop it in the chat box. We'll go back to the Jeopardy music. Do 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 bop ba da 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 boom boom boom. Chris, we got to get actual Jeopardy music or something fun as opposed to me doing this in the background for the future. But okay, let me know in the chat box. Let me know in the chat box. Help me out a little bit. And okay, getting a question mark. So realistically speaking, okay, you're confused. Questions again. All right, so let's try and approach this from a different perspective. Yeah, and it does begin on the 16th. So let's go back to subnetting. And when we do this, I'm going to subnet a specific subnet down. Just give me a minute. I think I've taken something and I've subnetted down. I think I've got a slide where I've taken a single network and I've subnetted down. All right, so I haven't. Let's just do it in real time. Let's look at this subnet over here, the 172.16/27. /27 means the subnet mask looks like this. 8, 16, 24 plus 3. So that tells us that our subnets are going to have how many people per host? So they're going to have 2. So realistically speaking, that means our subnet mask is going to look like this. So that tells us /20, 24, 20, 25, 26, 27. So that's our what we're dealing with here. So with a /27, if we've got 1, 1, 1, 0, what's that look like? 128 plus 64 plus 32. Somebody tell me what that looks like, because we actually, there's the good news is you guys are confused for a reason. Very good news. So let's do this math one more time. That's the challenge when we do some live stuff. We occasionally may make a math error. So what's 128 plus 64 plus 32? 224, everybody, right? So that's what this mask is going to look like. This mask is going to look like this: 255.255.255.224. Okay, so now how many hosts do we have per subnet? 2 to the 5th minus 2. 2, 4, 8, 16, 32 minus 2, which gives us 30. So now, with Mike doing the Mike math in the background, is 27 divisible by 32 with a number of greater than 1? No. So where does this subnet truly begin? This subnet begins at 172.16.1.0. And this subnet ends at 172.16.1.31. Okay, everybody, now tell me where the next subnet begins at. The next subnet will begin at 172.16.1.32, and it will go all the way to the 172.16.1.63, right? Good. You guys figured out the next subnet. So now what's the next subnet up? The next subnet begins at .32. The next usable address is .33. Ruth, you got it. It goes all the way to 63. So Ruth, now, where does the next subnet begin? 172.16.1 dot something more than 63. One more than 63.
Mike, can you pull that text box up some?
That would be a good idea. .64. Where do we think this is going to go to? Somebody let me know. Come on, can 64 plus 31, 64 plus 31, 64 plus 31 equals, hold on, no, yeah, 64 to 95, exactly. And the 95 is what? The broadcast address. Okay, so what do we think is the next subnet, Ruth? After this one, where is it going to begin? Come on, add 31 plus 95. Jeopardy music. Do 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 do. Ba da da dum dum. Ba da 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 da. Okay, so let's do it. Let's really look at that. Ruth is looking like she's doing some pretty good math. So we've got 96 plus 31, and where's that going to take us? All the way to 127. So we're going to have this is going to begin at 172. 72.16.1.96 all the way to go 31 higher, which I believe is 127. So it'll be 172.16.1.127. So where do we think is the next one up? Next one up. Next subnet, guys. Okay, so if this one ends at 127, where do we think the next one begins? Alexandros, Polikala, exactly, 128. Ruth, you got it. The next one is going to go 172.16.1. God, 128. Ruth, I haven't, 159 sounds about right. 159, because that is 31 plus that. So 172.16.1.159. I'm going to double check because this way I don't make any funny math. We're going to have 128. Whoops. 128. 128. 128 plus 31. Excellent. Okay, so all the way to 159. Now, what's the next subnet, everybody? Where do we think that would start? Where do we think this would go? It's going to be one number higher will be the subnet, which is used by the routers. Then the first host bit will be one more than that. And we go up 31 from the initial subnet address to get to the broadcast address. What would that be? $160, yes. 172. Excellent. 16.1.192 or 160 all the way to 191. Nice job. 172.16.1.191. All right, everybody. So what's the next subnet? We're going to subnet this whole one, and then we're going to do a different kind of subnet.
And Mike, just so you know, you are in front of that text. That table is one image, so you can move that table.
Okay, excellent. Okay, so now we've got it. 172.16.1.192. That's the subnet address. Okay, you guys did it all the way to 223. I'm loving this. Okay, so 172.116.1.223. Now tell me the last one for this subnet, and you can see how many networks were created out of this single one. Okay, where does this next one end? Start 172.1.224. Where does it end? Where does it end? Where does it end? What is the broadcast address here? Everybody see this. Everybody see this. Everybody see this. Ruth, you got it. Ruth, gold star for the day. You've gotten the math perfectly. And just yesterday, we were exchanging messages on networking, and wow, you got it. So, Ruth, fantastic. John Clark, fantastic. Summer Series Beamer, fantastic. Loving all of this. So now you know. But while we're at it, we're not going to take this is good enough. You're taking my course, you're going to be capable. So let's do something different. Now, let's go over here and do the /30. What's that going to look like? 255, 255, 255. Okay. Bingo, bingo, bingo. Now, where does this subnet begin? Let's start with the 0 subnet. We've got, let's say the subnet, it's a /30. Let's say the /30 looks like this. It looks like a 192.168.1.0/30. Now, where does this subnet begin? Where does it start? Somebody let me know. Where is that 0 subnet start and where does it end? We've got how many bits here? 2. So 2 to the second minus 2. So Angelo, I don't know whether you're Greek or not. Excellent. Elvis, fantastic. So the first subnet is going to be 192.168.1.0 all the way to the 192.168.1.3. So the .0 is used by the router for the subnet. The .3 is the broadcast. So now, somebody tell me my next subnet. So the first subnet is 192.168.1.0, and it ends at .3. Where's the next one going to go? Where's the next one going to begin? Ruth, Eugene, Kirshen, fantastic, you guys. I see it in this other monitor. You're coming in, you got it right. Exactly. The next one is 192.168.1.4 all the way to 192.168.1.7. All right, we're going to do one more of these because I want to know that you guys get it. And then we're going to go the other direction and do route aggregation. One more. Give me the next one. I'm greedy. You guys are doing so good. I just want to know you guys get it. I'm loving this. I'm so proud of you. Ruth, gold star. Jason, platinum star. I'm loving this. You got it. You guys got it fast. So, wow. 192. 168.1.8 all the way to 192.168.1.11. Woohoo, I'm loving this. Now in a couple minutes, we're going to go the opposite direction. And I'm going to show you why. Angelo, are you Greek with that awesome name? Because if you are, I'll call you Aguilo, which is the way we Greek people pronounce Angelo, since apparently you're not Italian, but wherever you're from is fantastic. Okay, so now we get it. So now let's do this. Now I'm going to open it up for some questions, and then we're going to go the opposite direction, which is always fun to go with regards to subnetting. So not really sure what's been going on in the chat box. Love to see what's going on. If you're having a good time, oh, and Hispanic, fantastic. I used to speak Spanish. One of these days I'm going to relearn it. Hit the like button if you're having a good time. Subscribe, hit the bell, tell a friend. Tell a friend. But until that time occurs, if you've got some questions, Chris from my team is going to bring you off mute, or not off mute. He's going to bring in the questions. So we're in a position where we can go out there and do whatever we need to help you. So, Chris, are there any questions in the chat box?
There was one from earlier in that session. Let me find it. Yeah, I gotta find it. It's way back here.
And yes, we do everything.
This was when the answer was starting at 32 and going to 63. I can't. That's all. That's all I can remember to jog my brain.
Okay, so Nitropan, I think what's going on is I actually did the math incorrectly the first time I demoed this, and I said 16 when it should have been 32. So Nitropan, I'm pretty sure that's what you're referring to. If that's not the case, pop it back in the chat box and I'll answer it. But the first time, it's a live show. I did a little bit of a mini miscalculation in my head, and then we fixed it. So that's why there was a little bit of confusion.
And to the person asking about subtitles, we can't turn them on while it's live. We'll have them on once the live stream is finished. The subtitles will be there.
Sounds good. If there's any others, ask them now. Otherwise, I'll get back into the content. I'm having fun with the content. It looks like you guys are doing great with the content, but I like to check in periodically with everybody to make sure you're having a good time, make sure you're learning, and that way it's a live class as opposed to like just something you watch. Chris, it looks like another question popped in. Do we always change the fourth decimal of the subnet mask? No, not necessarily. We could be going in the opposite direction, which we're going to be doing next. And Sarah Ahmed, that's an incredibly good question. When we mean decider, what we're referring to is we don't use Class A, Class B, Class C. It has nothing to do with whether it's public or private. It means we're not adhering to the /8, /16, or /24 boundaries, or those predefined things that somebody defined 30 or 40 years ago. That's all it means. Good question. What is the formula again? I don't know what you mean with regards to what formula. I will tell you to determine host per subnet, it's 2 to the X number of host bits minus 2. And calculating networks is going to be exactly the opposite direction. Chris, if you want to bring in the next one. Can you ask a question regarding codes on TCP UDP? If we're talking about error codes, that's not really part of anything like this. And that's not really in the network engineer scope of practice. Angela, you mentioned /24 LANs. Are there industry-specific recommendations? So pretty much /24 for LANs, /30 for WANs. Now, Angela, I will tell you, when you're designing LANs, in the cloud environment, you don't have access to a lot of the cool security stuff we networking can. But what we could do is we could do a /24 and still put our servers in one LAN, but we would create something called a private VLAN, which would make it that the servers in the same VLAN were logically isolated from each other and secure. We can't do things like that on the cloud because we don't have access to the switches. So we have much less security control on the cloud and much less security options. But in the data center, we can segment it out into just a couple of servers, and we can do private VLANs, and we can do MAC address lists in our VLANs, and we can do so many things in our VLANs to keep it secure. But if we're on the cloud, we lose most of the good security, and we're stuck with whatever the cloud provider gives us, which is about half of the security we can build in the data center. But cloud's still wonderful because it's so agile, it's magical. But in high security environments, typically speaking, you're dealing with firewalls and IDS, IPS systems and access control lists, 802.1x authentication, private VLANs, QoS policies, identity and access management things, encryption, routing authentication. I could go on for the next 6 weeks on how to do high security networking. And I've been doing it for a long time. Lots of things to do. When is the /8 ever useful? You know, a lot of times when I deal with a company and I design their addressing plan, I start with the /8. And the reason I like to use the /8 is it gives me the ability to say, okay, this /16 is going to Africa. This /16 is going to India. This /16 is going to Europe. This /16 is going to the US. And this /16 goes to South America. And then I still have so many addresses. And that way I can create a really nice BGP peering session between my regions if I choose to, or route summarization between my regions. So I always start with the biggest block I can, and then I subnet it out for the environments that I have. I learned early in my life, give yourself a lot more than you ever needed. Double it, triple it, multiply it by 10, and chances are you're finally going to get there. So, for example, everything you ever do, if you do it right, it's just going to grow. I remember setting up a voice system for a bank, and they thought they were only going to use it for 5,000 users, so they said 5,000, and I said, no. And I designed it to work with 50,000, and when they said 5,000, and they're like, Mike, we want 5,000. I said, okay, I'm still building the same foundation for you. And in the end, I gave about 8 presentations before the bank adopted my design. And you know what happened? 6 months later, 30,000 phones. And you see, I knew this was going to happen. So basically what I like to do is I like to build in the ability to scale and the ability to grow everywhere. And, you know, when you're a network architect with a lot of experience, you start to see customers have no idea what they're going to need in their network. And then, so I always start with a /8. But, you know, those are those things that you learn. Like, I wish I could say after being a CCIE for about 10 years, that's when you start really learning all the stuff that you've seen people break. And then you're like, okay, we've got to do this, this, and this. But it's a great question there, Network Bra. An extremely good question, because normally there'd be no reason to use anything like that. But I like to give myself a lot of room to grow. How many bits in a routing table? I'm not really sure what you mean by that. Because if you're dealing with a IPv4 subnet, you're going to have a 32-bit address in a routing table. If you're dealing with an IPv6 subnet, it's going to have a 128-bit hexadecimal address for each route in the routing table. But it's not about how many routes in the routing table. It's about how many routes in the routing table. So if I connect to 3 different internet service providers, typically speaking, I take in about 800,000 routes per internet service provider. If I'm dealing with a customer that has 40,000 remote locations, which is nothing for me, I'm dealing with 40,000 subnets just for the WAN links. I'm then dealing with 40,000 subnets just for the loopback addresses on each WAN link, on each router for the most part. And then I'm dealing with as many subnets as I need for the LAN links, which is probably another 15 or 20,000. So it's pretty normal to me to deal with enterprises that were nobody thought of their IP addressing plan, and they've got 100,000 routes in the routing table. So, and then they have problems, and then they hire an architect like me, and we basically re-architect their network, re-architect the designs, put this subnet's here, this subnet's here, and then share routes and route summarization. Everything works great. So whoever's doing your IP addressing really needs to be good at network. Usually the most senior person you have. Can I explain the parameters of a 3-day handshake? Sure. Hey, Chris, I'd like to talk to you. Are you willing to talk to me?
Sure.
Okay. Chris says, okay, Mike, I'll talk to you. And then I say, okay, Chris, you agreed to talk to me. Now I'm going to talk to you. That's the 3-way handshake. Great question there, Yash. Excellent question. Chris, you want to bring in the next one? All the rules change with IPv6. It's a slightly different version of subnetting, but we're going to talk about IPv4. My recommendations are as follows: /30 for WAN links, /24 for LAN links. pretty much used that in 95% of the designs over the last 25 years. Jason Henry. Okay, here's the biggest joke. What's the difference between a cloud and a data center? The cloud is somebody else's data center. That's it. Literally speaking, the cloud is just somebody else's data center. No more than that. So when you go to the cloud provider, what do they have in there? They have servers in there. They have routers in there. They have switches in there. They have storage in there. They have firewalls. They have load balancers. And that's their network. They've got big switches. They've got big routers, all of it. Standard data center. What do they do then? They install the cloud control plane software. And then they chop it up into a virtualized environment and sell you access to their cloud. Now, mind you this, because it's a virtualized data center, it doesn't perform as well as the regular data center. It's always going to be slower than the cloud. In the cloud, but it's super agile. I get what I need. So what makes the cloud possible? They have a high-speed network connection to the cloud. If you didn't have a high-speed network connection to the cloud wouldn't work. So the cloud is just a data center, somebody else's data center that's virtualized. Why is everybody confused on the cloud? I'm going to tell you right now. Because Amazon decided initially to come up with crazy names for their stuff. So, Amazon doesn't call a virtual machine a virtual machine. They call it an elastic compute cloud. Those of us that are architects, we deal with object storage. Amazon thought it would be cool to call it Amazon Simple Storage Solution. Heck, Microsoft decided to call it Blob. Google decided to call it cloud storage. So in the end, people don't even realize that it's the same 30-year-old technology that we're working with forever. AWS, brand new thing. You can route between subnets. Okay, thank you, AWS. Cisco did it in 1985. So the cloud is just a network in a data center that's virtualized. Now, that doesn't mean I don't love AWS, Google, and Azure. I think they're incredible. But if you actually call a router, and you call a switch, and you call a firewall, and you don't make up a bunch of words to make it complicated, you can do it. Cisco calls routers. They don't call them elastic traffic interprocessing units. They call it a router. You go to Juniper, they call it a router. Everybody knows what a router is. You go to the cloud, they got 50 different names for a NoSQL database. They got 50 different names for firewall. Seriously, call a spade a spade. Would you ever create a WAN connection to the cloud? Dan, you can't have cloud computing without a WAN connection. Okay, think about it this way. I'm at my desk. I want to access my servers, which are on the cloud. If I don't have a wire to them, I can't access them unless they're publicly facing servers. And then how would I manage them without doing all kinds of crazy stuff? So you have to have a connection to the cloud. In fact, Dan, you not only need a connection to the cloud, you need a backup connection to the cloud, and you most likely need a backup connection to the cloud. Well, again, I really don't understand because I see acronyms here. Now, PBR may be peanut butter rotation. PBR could be policy-based routing. PBR could be a test that I run on my patients to check for mental health illnesses related to an STI. So, Genius, I don't know what you mean because you're using acronyms. If you can please tell me exactly what you want, I can answer your question. What are the advantages of using contiguous networks? We're going to get to that immediately. Pretty much we explained the parameters. I send a SYN, someone acknowledges my SYN with an ACK and then sends to me, and I go back to them. So it's the same thing as I described before. Hey, Chris, willing to talk to me? Yes, Mike, I'm willing to talk to you. Okay. And I say, and he says, good. He sends a message to me. I say, good. And we're over there. So, realistically speaking, we're that. So if we had anybody translate their acronym, we can answer it. Otherwise, we're going to go back to the concept. Okay, so let's get back to the content. Let's talk about subnetting, but the opposite direction. Okay, so why would I want to do this? Why would I subnet in the opposite direction? So let's think about it. Generally speaking, we use what? /30s for WAN links and /24s for the LAN links. So what does that mean? Well, Every time I create a subnet, I have to tell every device in the entire network about that subnet. So let's go play with this. Let's ask some questions. So let's think about this. Every subnet that we create needs to have another route in the routing table. But here's the thing. Right now, so I'm going to show you why we have to do this. Actually, let's go through the math first, and then I'm going to show you why. So 192.168.0.0 and 192.168.1.0, are they contiguous networks, meaning the first /24 is 192.168.0.0, and the next one up is 192.168.1.0, and the next subnet with the /24 will be a 192.168.2.0, and the next subnet on the way up is 192.168.3.0. So while I might want these /24s as my actual subnets, which I do, and the reason is it's about the maximum number of hosts I can put in a subnet before I run into problems. So there's that. But what if I don't want to send this many routes? Now, for example, let's pretend you're in the cloud. Now, if I connect to 3 internet service providers, I take in 800,000+ routes from AT&T, 800,000+ routes from Verizon, 800,000 routes from, say, NTT, and maybe another 800,000 routes from CenturyLink. Now, I've got the best path to multiple destinations on the internet, and I can make a decision. Now, let's look at here. I'm taking in 2.5 million, but if you're dealing with a cloud provider like AWS, they only let you give them 100 routes. So how many routes is 100? None. I mean, none. I've never seen a 100 route network in my entire life. So, but I've had to summarize a lot of routes to get into that 100 subnet range. And I'm going to tell you, the secret to making your network scale and be high performance is having the intelligence where you need it and having the lack of intelligence where you need it. So look at it this way. If I had 3 locations, if I had a location in Florida, a location in England, and a location in Athens, if Athens had 1,000 subnets, and England had 1,000 subnets, and America had 1,000 subnets, guess what? England only needs to know about the single subnet site or range that I'm using. Greece needs to send me their site or range. England needs to send me their site or range and send Greece their site or range, et cetera, et cetera. By doing that, I can put one route in between our organizations. Now, once the traffic gets to the organization, they're going to be smart. So what's it all going to be like? So let's say Chris is in the Tampa, St. Petersburg area. If I knew how to get to Tampa, St. Petersburg when I wanted to go to Chris's house, and I had one path to Tampa, St. Petersburg, and I got there. And then I'm sitting in Tampa, St. Petersburg, and now I call Chris on the phone and say, Chris, how do I get to your house? And he says, make a left, make a right, make a left, make a right. Well, that's what routers do. We can set this up where you know where to go. And then once you get there, the path goes through the most intelligent path without doing this. So we're going to talk about why. So these are contiguous networks, which I see a lot of you have. So now let's think about this. Now let's do our math again. If we do this in the other direction, if we do 192.168.0.0/23, move the host bed over. I got an extra network bed. Now, how many does that mathematically equal this? This plus this? Will this cover these 2 routes? The answer is it does. Now, what kind of a route do you think I could create? What kind of a subnet do you think I could create out of here? This could also turn into a 192.168.2.0/23. Okay. Now, what if, now I could now send 2 routes as opposed to a single route to AWS, for example, if I was using the cloud. Now, do these 2 routes, can I summarize them down to 192.168.0.0/22? Does this encompass all of this? Yeah, it does. Yeah, it does. So let's have a little more fun with this. And let me actually fix some of these slides. I am very privileged. I have some really good graphics people assist me. But every once in a while, the numbers that I put on my little napkins that I say, here, please draw this. Sometimes I could do a better job of giving my graphic artists, who are really incredibly talented and wonderful and super smart people, a little better information than just what I do give them. So let me just fix these addresses real quick over here. Okay, 5, 6, 7, and then let's get rid of this. Okay, so now let's look at these. 10.0.0/24, 10.0.1.0, 10.0.2.0, and 10.0.3.0. That's a /22, right? I can aggregate all of these as a /22. So it'll look like this. It'll look like 10.0.0.0/22. Now, what if on the bottom, 4, 5, 6, 7, I decided to summarize these into 10.0.4.0/22? And now, what if I decided to aggregate these two together into the following? N dot, oops, .0.0/21. You guys see this, how we're creating summary addresses? So why, Mike? Why are we doing this, Mike? I don't understand. Why does it matter? Why are you saying these addressing plan is so important? If you do your addresses right, and we use what's called contiguous addresses, I'll show you why it's so elegant. And if you do this wrong, I'm going to show you how we break things. And we can break things really easy here. So now let's look at this. This was someone that does not know a lot about networking. This is someone that's a Unix sysadmin, a Linux sysadmin, and somebody said, hey, you're a network engineer for the day. And they said, but I don't know networking. And they said, guess what? Get a subnet calculator. So in this particular environment, we've got this person that put 3 subnets in the data center. Now, mind you, we'd have 300 subnets in the data center, but let's say it's 3. And 1 subnet on the cloud. Now look, 10.0 is here, 10.0.1 is here, but 10.0.2 is here. So how many routes do we have to send to the data center for the cloud to make this work? Every one of them. And how many routes does the cloud have to send us? It's 1. Is there any magic that I can do here? Absolutely not. Absolutely not, because our subnets are not contiguous. Now, granted, I could put these 2 in a /23, but it's ugly. It's ugly. So by comparison, let's look in this environment. Let's say we had somebody that was smart, that knew a lot about IP addressing. And let me move this over to another slide so you can see this, because my head's kind of over there. So let's say on the cloud, we used 4 contiguous summarizable subnets. And in the data center, we used 4 contiguous summarizable subnets. Now, the cloud only needs to send a single route. The data center only needs to send a single route. Look how scalable that is. So how are we doing this? Why does it all matter? Why do I like my /8s and why do I begin? We begin this for the following. So look at it this way. Data center. Because this is really what we're talking about now. And this is real networking. And this is the kind of stuff network engineers, cloud architects, solution architects are going to be dealing with in today's world. Let's say this is going to be AWS. They're always going to be on 2 clouds for the most part, because the single cloud is a single point of failure, no matter how many availability zones you use. And all the cloud providers have proved it to us with multiple global outages this year. And what are we typically going to do in one of these environments? We're going to have a couple of routers on each side, router here, router here. Well, actually, it's going to be 2 routers, but just for argument's sake. So we've got a couple of private lines going in each direction. You've got a private line in this direction. Now, look at this. If we start with this 10.0/8, so in the data center, look, 10.0.0.0/16, because I'm subnetting my /8 down. Now over here, I'm going to have 10.1.0.0/16. Now down here, I'm going to create another one over here. Now, how many routes need to be sent anywhere? Guess what? I'm sorry, this is a 10.2. Azure needs to send one route to our data center. AWS needs to send one route to our data center. And we may have 1,000 subnets in our data center, but we only need to send one. All we need to do is tell either provider over here, hey, by the way, this is all you need to do is reach 10.0.0.0/16. So one route. When AWS says, hey, we can only take 100, we say, 100, no big deal. We had some CCDE and CCIE networking people design our networks. You can have one route. Or most likely what I would do is I would probably leak a specific subnet on this route, and it leaks a specific subnet on this route, add an aggregate route on both, and then I could load share and have 2 links and not have any out of order packets and magic, and life is beautiful. So it's beautiful. That's why we have to be careful. That's why we want contiguous subnets. That's why the person that's doing the IP addressing needs to know a lot about networking, because that is the most complicated part, is determining your addresses and determining your subnet. So go back to this, play with it a little bit more. And the next thing we'll do is we're going to calculate some more subnets. We're going to analyze some more subnet masks. And I'm going to make sure by the end of the day, every one of you has a good grasp of IP addressing, subnetting, and everywhere in between. So let's do this. I don't know how long it's been since I've taken questions the last time. So Chris, if you want to check and see what kind of questions were there, let me know. If you're having a good time, please hit the like button, comment, forward to friends, for example, and I'll wait for some questions to come in. Difference between an access switch and a core switch. What a great question. And we start talking about architectures. We're going to talk about the core, distribution, and access layers. But I'll give you a little bit of a brief answer right now. The core is our fastest routers we've got. They're layer 3 switches. They're routing real fast. Above that, what do? We have a set of distribution switches. And what they do is they bring stuff into our core. And then we plug in switches called access switches, which is basically where our users are. So we typically segment our network into the core. Think your biggest, baddest routers. Distribution, connections to you, to the core. And access is where your users plug in. We will spend a lot of time on these architectural concepts because they are very important when we do that section. But great question. Chris, if you want to bring in the next one. Will you be using supernetting on your WAN connections to the cloud? You won't have a choice if you're dealing with normal networks, because the cloud providers only take like 100 routes, which is absolutely nothing. No. Dan DTM, why? If Amazon has 1 million customers and each one sends them 100 routes, that's 100 million routes. That's a lot of routes. So you got to look at why they're in this predicament, because they've got millions of customers. So, when we say a normal router can handle a couple million routes, if we're dealing with an internet router, we've got to remember they've got a lot of them. So because of those extreme limitations on the cloud, and we've got extreme performance limitations everywhere on the cloud. Everything we do in the cloud, we're going to have to modify our subnets. We're going to have to do extreme workarounds to make the cloud secure, virtual firewalls with load balancers and virtual IDS, IPS systems, because we can't do a lot of things. Layer 2 access control with 802.1x authentication, private VLAN. So we got to get extra cautious. So we'll almost always be supernetting on our WAN connections to the cloud. Chris, you can go to the next one.
There's not any other questions right now.
Wow, fantastic. So if you guys are caught up, not having a million and one questions, let me know you're here by typing hashtag CCNA. Hashtag CCNA. If I see about 100 of them across the screen, I know you're awake and you're not sleeping. We'll get back to the content. Okay, it looks like you guys are getting it. I'm pretty happy. Let's do a little more examples together. I rather do this than go through some prepackaged content. Let's do some subnet mask conversions. So let's do this. Let's take a class A address. We'll take a 10/8.
Make sure to share your screen, Mike.
So what's this going to look like? It's going to look like a subnet mask of 255.0.0.0. Okay, everybody see that subnet mask? Okay, so now everybody, let's do a little bit of architecture work. New York. Let's pick a couple of cities where we've got lots of wonderful students throughout the world. Let's say we've got New York. Let's say we've got London. We've got a really magical student over there in Hungary. So we're going to say Hungary. Or should we say Bulgaria? So we'll say Hungary because even though she's from Bulgaria, she's in Hungary. And because she's in Hungary and I'm from Greece or my family's from Greece, we're going to put Greece over here. You know what? While we're at it, let's pop in a location in Dubai. And while we're at it, let's have a little bit more fun. Let's add another one. Let's add Lagos, Nigeria. It's becoming very rapidly a pretty big tech location. So these are kind of the environments that we have. So now let's say we need to create a really high performance network between all of these. And you're given the subnet and the address block of as follows. 10.0.0/8. These are the addresses that you have. Now you will never have, ever, ever, ever have the need for more than 32,000 addresses per location or subnets. Ever, you will never need more than 32,000 addresses per location based upon subnetting size. So what does that mean? 32,000. So how many addresses do you have right now? 10.0.0/8. 2 to the 24th minus 2. Somebody want to do that kind of cool math and tell me how many addresses they've got? 2 exponent 24 minus 2. Two exponent 24 minus 2. Somebody give me that math. Somebody give me this math. 2 to the 24th minus 2. 2 exponent 24 minus 2. Ah, Jason got it. Alexandros Polikala. Fantastic. Kersing, you got it. I'm seeing it. You guys got it. So we got a lot of addresses to use. 16,770,000 exactly. We got a lot of addresses. Are we going to ever need that many? No. Nowhere close to it. So I said you'll never need more than 32,000 addresses. So you could give me for 32,000 addresses, or you could say, I got 16 million. I'm never going to run out of them. Let me do something more. So if instead we looked at it and said, we think we only need 32,000, but we want to double it, we could use a /16. So 2 to the 16th minus 2, everybody. 2 to the 16th minus 2. Tell me what that turns into. Two to the 16th minus 2. 2 to the 16th minus 2. Jeopardy music. Okay, so 2 exponent 16, Alexandros. Polioreo. You got it. It's like 65,000, some crazy number. Kershang, you got it. Fantastic. So I said you're never going to need more than 32,000, but Babita, yes. Jason Henry, Jeannie, Sarah, all of you guys got it. Perfect. Perfect, Sanchin, perfect. So what if we were to do this? If we make New York 10.0.0.0/16. And let's say that we made London 10.0.1. I'm sorry, 10.1.0.0/16. And we decided to make Hungary 10.1.0.0 or 10. I'm sorry, it's going to be .2. These are all beautiful contiguous subnets /16. Now let's say we've got Greece that wants to use 10.3.0.0/16. Let's say we've got Lagos. We've got a lot of wonderful people in Lagos, Nigeria. We've got 10.4.0.0/16. And we've got Dubai. 10.5.0.0/16. Okay, now let's look at this. Add some networking connections. Add a bunch of networking connections. We'll have some fun over here. We'll connect this to this. We'll connect London to Hungary. We'll connect Hungary to Greece. I'm going to move Greece over here for a reason. Then we're going to move, we're going to connect Greece to Lagos. Then we're going to connect Dubai to Lagos, Nigeria. While we're at it, we want a little redundancy. New York and Greece are really important because my family's there, so I'm going to have another connection there. London and Dubai have a lot of business relationships. And Ivadoikia over there in Hungary works with a lot of my students in Lagos, Nigeria. So now we've got a full mesh environment. So there's this. Now, realistically speaking, we decide that we're going to connect to the cloud. We decided that we're going to connect our New York office to the cloud. And we're going to have 2 direct connections, private lines from New York. What subnets does the cloud need to know about, realistically speaking, to make the optimized routing work? We've used contiguous subnets for everything. I can send, how many subnets do I need to send to the cloud for them to be able to reach back to all of my locations? Okay, so I'm asking all of you guys, how many subnets do I need to send to the cloud to make this work? Just to make, Jeannie, yes, Jeannie, yes, I'm so happy. All I need to send is 1 subnet. I can send a 10.0.0/8 or could I somehow summarize this, 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 and this, and this into potentially a 10.0.0.0. Now, how many bits would I need to go to cover 1, 2, 3, 4, 5? I don't have to send the full 10/8, right? I could send a 10.0.0.1. All I need to do is accomplish the subnets from 0 to 4, and then I can probably go to 10. So yeah, exactly. I could do a /10 and send a single subnet. Or I can send this. Or what could I do? I could say, hey, on this link, we got a lot. I could load share. I could say on this link, send 10.1, 10.2, and 10.3. And on this link, send 10.4 and 10.5, and then a summary route just in case the links fail. That's what we're talking about. That's what we're trying to architect around. That's what we're designing them. Making sure we only send what we need when we need it and nothing more. That's what we're trying to talk about. And that's why this matters. So let's look at some basic subnets that my team drew just to walk through it. Here we go. We've got a server 172.16. It's in the 1.0 subnet. We've got a /24 for a WAN link, which means we wasted how many addresses? 254 minus 2. So we've wasted 252 addresses by using a /24 on a WAN link. That's what we use /30s. Okay, now let's see this. R1 connected to R2, another /24. Now we've got a /24 on the LAN, which is perfect. And that way this system, she can talk with her and he can talk with him. So, this is a perfect kind of design in the way we'd naturally do these things. So let me just look and see if there's anything more I want to cover in this section. And then maybe we should configure some subnets on some routers and then try and play with it. So let's do this. Let's open it up for a couple minutes of questions, even though I don't think there's going to be that many. And then we're going to start to get to some labs, have some cool fun on some routers. And we'll get into operating Cisco routers, which is all kinds of fun. So are there any questions before we go into the next chapter? Chris, is there anything for me before I get?
I'm just waiting to see if there's any questions.
Sounds good. Yeah, we are in a delay between you and us and them. How many parts are left in this series? I think we've got about 7 or 8 days left. It's a lot of content here. Please go back and watch the first 2. They're there. We're going to leave them up permanently. My /10 because we had a /8 and we wanted to go up one more, which would get us to a /9, which would give us the ability to aggregate 2 of them. And then we wanted to aggregate 4 of them, which would get us to a /10. And then actually wanted to aggregate 11. We wanted to aggregate 8 of them, which would actually be a /11. It was someone in the audience that said /10, and I didn't do the math myself. You can watch these videos, Jim Weaver. We don't provide our intellectual property or our own internal slides ever to anyone. Any other questions there, Chris?
Not yet.
Okay, well, if there are not, keep going through the content, which I'm totally always happy to do. So let's have a little bit of fun. So let's look at a couple of different kind of situations. Typically speaking in networking, we're going to have something that looks like this. We're basically going to have our data center, which we're going to call a central site. And that's going to plug into a WAN router, which is either going to have an Ethernet port or it's going to have a serial connection. And if it has a serial connection, what we have to deal with is we deal with something called the CSU DSU. So what happens is we call the phone company and they bring in a WAN connection to our house or our DFS or data center. They terminate it in something called the CSU DSU. And basically that is their stuff. That is the point of demarcation between our network and theirs. Now that CSU DSU supplies some information to our routers, such as clock rate, etc., etc. So, keep that in the back of your mind, that we have that cable. And with that, it provides that. So typically speaking, that's the way a WAN works. Provider comes to you. They basically terminate their equipment or their data communications equipment. It looks like a CSU DSU, and we plug it into our devices. Alternatively, there are some routers that we can plug that internally to the router, but basically speaking, that's something that terminates the connection. So now we're getting into the official Cisco way of the way they like to teach you how to configure their routers. So let's teach it the official Cisco way right now. I've been having a lot of fun with you guys, just making some stuff along the way. And I like doing that for a reason, for the following reason, and it gives you guys a chance to really get good at stuff. So, but let's just play right now with a single router. Let's close this lab. We'll create a new one. And as soon as I do, I'll share my screen. There's lots of simulators out there. By far the most robust is EVE-NG. EVE-NG is what you use if you actually worked at a networking company. It's what you would use if you worked at a consulting firm. There's some free things like GNU3, but they're not real robust. They're good for practice labs, but if you really want to test anything for real, you're either going to need to buy real routers, you're going to need to buy an EVE-NG server. There's a community free version of the server you guys can use, and it's great. We obviously is a much bigger, more sophisticated thing because we're a school. So let's keep that in the back of your mind. We're just going to call this basic router config. Going to see if it needs us to do this. So now we're going to add one router.
Hey, Mike, you're showing your slides, not your EVE-NG.
Oh, well, I knew I was doing something goofy. So thank you so much. So here we've got our router. Let's launch a router. We're just going to give it extra Ethernet ports because we don't know whether we're going to need it or not. Going to make it work. Oops, I didn't mean to do that. So let's come. Now we're going to turn on a router. Now we're going to console into the router. And this is going to be like any other router. What is it doing here? I'm going to tell you right now. This simulator is basically a server that has server virtualization. The server is running in multiple virtual machines and or containers based upon what's going on, the different devices we're using, individual routing software. So if you go to many kind of major tech company, they're going to be using something like this, and they're going to be running simulations. They're going to be testing firewall software, router software for whatever projects they're going to be using. And you can connect these systems to your network, push huge amounts of traffic to your network. This stuff is really, really cool. When I was younger, we literally built out proof of concepts for all these things. Now organizations are using these kind of tools, specifically EVE-NG, to do proof of concept testing. Fantastic, fantastic, robust software package. Otherwise, you can buy a CCNA rack for about $150 to $200 on eBay. Again, very helpful. We're going to let this system boot. So come on, router, wake up, wake up, wake up. It'll be with us in a minute or so. Okay, so Router comes up. Would you like to enter the initial configuration dialog? Never. The answer is no. Would you like to use DHCP to assign an IP address to your router? No. Would you like anything to be automatic? No. If you do, here's what's going to happen. You're going to have network devices that are going to change addresses. You're not going to be able to find anything, and it will be a nightmare. Literally speaking, a nightmare. So everything's going to be static. So I talked about it a little bit, but I want to make sure you guys know it. So we are right now in user mode. User mode, meaning can't do much. I can do a little bit of show command, show IP interface brief. Let's see if it even lets me do that. Lets me see some stuff. Okay, what do we see on this computer? Router, same thing. We see 16 gigabit Ethernet ports. Wow, that's a lot. Now, are they up? No. Gigabit Ethernet, unassigned. Method, okay. Administratively down. What does administratively down mean? It means in the configuration. So run int T0/0. Let's look at this interface. What does it say? Got an interface? There's no IP address on it. It's shut down. That's not why it's working. So let's add another router. Node. Cisco iOS router. Let's give this guy 16 ports too. I have no idea what kind of labs we're going to have fun building today. I mean, I've got some labs planned, but you guys are doing so good today. I might just have you guys do some more fun stuff along the way. Let's start this guy. While we're starting this router, while we're at it, let's create a connection between these two devices. G00, G00. Okay, now that's going to change things. Okay, so now you can see our routers side by side. Router over here. So let's go back to this thing. Now let's configure this thing. So we can show interfaces, show IP interface brief, which is going to give us a list of everything. We can do show interface G0/0. Now watch what we see. We see everything. We get to see the hardware. We get to see its MAC address. We get to see the maximum transmission unit, the bandwidth, the delay. And this is administrative things that you set, the reliability, the load, et cetera, et cetera, et cetera. So next, what do we do here? Probably should put a name on every computer, right? If you've got 1,000 devices that say router, will you be able to find it? Of course not. So how do you do this? Config T. That enables you to get to what? Configuration mode? We'll put a host name. Host name. R1. Nope. It changed. Let's see what else is next. So now let's go to this router. Let's go back. Let's go in it real quick. Let's go into this device. Would you like to enter an automatic anything? No, we don't do any automatic everything. Okay, let's just give this thing a name, because if we don't, we're going to run ourselves into trouble. We're going to go to the interface. We're going to give it a host name. Let's call it R2. Host name R2, so we can identify it. Now let's go to that interface G0/0 where we've created that connection. Let's give it an IP address. let's say 192.168.0.2. Let's give it a /30. 255-255-255-252. We're going to turn on this interface. We're going to store that so it doesn't go. Now, let's look on this. Let's look on the device where we actually turned this. Let's go with show IP interfaces brief. Now, look what we saw. We just put a gigabit Ethernet link up here, and it is manual up, up. Good. Now, let's see what happens if the link goes down. Watch what happens if the link goes away. If it'll let me. Let me bring the link down. Link's down now. Let's see what happens. Ah, look at that. Look at that message. So we'll do a show IP interface brief. Now look, it's manually enabled, but it's down. Why is it down, everybody? The link is dead. Let's bring the layer 2 link back up. Watch what's going to happen. We should get a syslog message on our screen. It's going to come. It's going to tell us interfit gigabit Ethernet 0/0 change state to up. Oh wait, there it is. It came up. It came up. Okay, so now let's go to router 1 interface D0/0. Can anybody tell me what's the other IP address that belongs on this subnet? Everybody tell me the other IP address on this /30 that goes on router 1 that's in that same subnet. We'll put on the Jeopardy music. Do, 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 pop, 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 pop. Okay, what's the IP address on this subnet, everybody? Elvis, nice job. All right, Elvis, I'm loving that. So we've got a one. Oops, let's make sure we're on the right router. We've got a 192.168. Good job, Alex. 168.0.1. What's that mask look like? 255.255.255.252. Okay, well, we'll probably have to tell it the words IP address. So how do you go to the beginning of the line? Control A. We can type IP, ADDR, and now we pop it in. Now, is this link up? Is this link up? Okay, everybody tell me, is the link up? Interface gigabit Ethernet 0/0. IP address 192.168.0.1. Status administratively down. What does that mean? It means I haven't turned it on. Ding, 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 ding. Okay, you guys got it. So can I ping across this link right now? If the port is down, can I ping this 192.168.1 or .0.1? If I can, we got a problem. Time out. Time out. Time out. Time out. Now, if we go to router 1, config T, interface T0/0, and we say turn on, no shutdown, watch what happens. So, configured by the console, line protocol and gigabit Ethernet changed to up, up. So, now are we up? Well, let's go back to the router on the other end. Let's repeat that ping. We're going to lose the first one, and then we're going to have the next 4 go through. Now, each subsequent ping, 100% get through. So why? The first ping, we lost one. Here's why. We did this. ARP! Who has the MAC address for 192.168.0.1? And then guess what? The other router respond, I have it, but it took some time. And that's why we lost that first ICMP echo message, our first ping. That's why. Now you know why. So let's add another. So now we're there and we kind of get it. So we can now ping across the link. While we're at it, let's create a host. Let's add an additional interface to this, config T. And here we're in the terminal, we're going to create a loopback address, interface, loopback 0. IP address, we're going to pick a wacky one. Let's say we choose 1.1.1.1. We're going to give it a host root of /32, 255.255.255.255. It's a host root. No shut. Now, when we look at this, show IP interfaces brief. Ah, we got it. Can we ping our own interface on this router? Make sure it's up. Yeah, we can. Now, if we go to this router over here, router 2, can router 2 ping 1.1.1.1? You guys think it can? Can router 2 ping 1.1.1.1? Why yes or why not no? Well, let's try it. Can router 2 ping 1.1.1.1? No. Why not? Why does router 2 not know how to reach router 1's loopback address? Can't reach it. Now, we could say we have a drunk router, but while we're at it, let's have some fun. Let's create another interface on this router. Int loopback 0. 2.2.2.2. We got to tell it IP address. IP ADDR 2.2.2.2. 255.255.255.255. Now, that interface exists, so IP int brief. While it's there, ping 2.2.2.2. It's local to the device. Woohoo, I can reach it. Now, can I reach it from the other side? Ping.2.2.2. Can. Wonder why. Anybody want to know why I can't ping the loopback on the other router? Why each router can only ping across the wire, but it can't reach any other subnet. Now, why can't we reach these other subnets? Why can't I reach that loopback segment? Anybody know? There's a very critical reason I can't reach that subnet. Okay, well, I'll give you a hint. I want to go to Eva Doike's house. She's in Hungary. I don't have a boat or an airplane. Can I get to Eva Doike's house over there in Hungary? Answer me yes or no in the chat box. I want to go to Eva Doike's house. She's in Hungary, and I don't have a boat or an airplane. Can I swim across the Atlantic Ocean? 3,000 miles without getting eaten? We don't have any path. There's no route. So I want to go visit Eva Doike over there, the Miraculous Brew Ranch. Super, super smart, wonderful, wonderful person. One of my amazing students. I can't because I can't swim 3,000 miles in the ocean without dying or getting eaten by sharks, hypothermia, etc. I don't have a route. So could we configure a route? Sure. Config T, IP route. You could do 1.0.0.0, 255.0.0.0. What's the next hop? 192.168.0.1. Now, what's going to happen if I ping it? Woo, we got it. So now, on router 1, can we ping 2.2.2.2? We can't. Why? Why not? Why not? What does router 2 know about? What does router 2 know about? Router 1 doesn't know about how to reach it. So we got a couple options. Config T, IP root 2.0.0.0/8 or 2.0.0.255.0.0.0. Next up, 192.168.0. This guy's 2 on this side, right? Pretty sure it's 2. We have to get the right next top right, or everything's going to break. .2. Okay. Oops. Now I go over here. Now can we reach that? Can we reach that loopback? Yeah, we can, because we have a path to it. So let's think about this. Now let's come up with a different kind of route. So show run. Now let's look at the routing table. What do you see here? You can see we've got the loopback. We've got this. Let's look in our. Let's see. Do we have any static routes in here? Okay, you can see Mike's put a static route here. Now I'm going to get rid of this route. Yeah, I don't know what the heck happened there. So we're going to go to config P, no IP root 1 or 2.0.0.0. Oops. 0. 255.0.0.0. 192.168.0.2. Make sure that removed it. Check. Now we don't have that route on the routing table, so can I ping it? Oh. Now what if instead of giving a route, putting it on the routing table, I said to the router, if you don't know where to go, send everything to the router 2. Let's try that. It's called the default route, which says if you don't know where to go, IP route. This means all unknown data, 0.0.0.0, 0.0.0.0, 192.168.0.2. Now I gave it another route that says if you don't know where to go, go here. So let's see what happens. We can ping it. Working. So what we really need is some form of a route that says go here versus go here. Now, could we have just used the routing protocol? Sure. We can do config T, and we can do no IP route 0.0.0.0, 255.0.0.0, 192 or 192.168.0.2. Make sure we got rid of that out of the routing table. So it's not, let's just ping it. Okay, we can still ping it, which is not good. I don't think I erased it completely. I may have made a typo, which apparently I did. So it should say config T, no IP route 0.0.0.0. 0.0.0.0, and the next top, let's make sure we get it right. 192.168.0.2. Make sure that got out of the running config. And what we can do is we can walk through just some other ways to look at this and see how we could do it. Okay, good. So now we shouldn't be able to ping this again. We need to do that. Okay, good. That's not working. Now let's do this. Let's go to this window, do a show run. Let's get rid of the static routes we put there. I showed you we did a static route. And then static routes basically are if you want to do this. So no, okay, so config T, no IP route 1.0.0.0 255.0.0.0 192.168.0.1. I'm pretty sure that was the address we have on the outside. Yep. Okay, this should be right. Make sure we got it right. So let's just do a show run. Okay, good. So now we shouldn't be able to ping this side. Okay, so now let's just pretend for a second we were to turn on a routing protocol. So let's do it. We'll go config T. We'll do router OSPF1. I will basically put in 0.0.0.0, 255.255.255.255, which basically says accept everything. We'll pop it all in area 0. I'll go to the other router on the other side. We'll go to config T. We'll do router OSPF1, which is we're basically turning on a dynamic routing call protocol called OSPF, which I'll talk about in depth. Network 0.0.0.0, 255.255.255.255, area 0. Now we could get a little more precision when we did this, but we're not going to do this for the following reason. I'm just looking to get your stuff as fast as we can in here. So let's see. Let's make sure that we've got show IP OSPF interfaces. Let's make sure we've got it. Okay. We can do a show IP OSPF neighbors. And we can see that we're forming a neighbor relationship. Now we're in two-way. We need to get to full to where we're going to start to see routes in the routing table. So what should happen is in about a minute, we'll get a syslog message pop up on our screen. There you go. OSPF adjacency change, process number, Ethernet loading to full. So you think we can ping across the other side of the link now? Well, let's see if the route's there. Show IP route. Wow, we got a route to this. We learned it via OSPF. So let's ping it. Now let's go to the other side. You think we can ping the 2.2.2? Let's see. Yes, because we turned on routing. So, okay. Can we do this? Config T, no router, OSPF1. Would help if you could type. Okay, let's go over to here. Clearly that brought it down. Config T, no router, OSPF1. Let's try another routing protocol. Router, EIGRP. And I haven't used EIGRP since my CCIE exam 20 some years ago. Router EIGRP1. Let's just do this network 2.0.0.0 network. Let's do this. What do we have? 192.168.0.0. It's just another routing protocol. No auto-summary, because otherwise it'll summarize it. Now, let's go back to the other router. Let's do the same thing. Router EIGRP1. Network 1.0.0.0. Network 192.168.0.0. No auto summary. I haven't configured EIGRP for a very long time, so I may have misconfigured this, but we'll see. Because I may have actually put in the wrong kind of show IP, and if not, I'll EIGRP. Fine. Okay, so that's participating. What about this one? Okay, so for some reason they haven't formed an adjacency. I'll go figure that out. I most likely misconfigured EIGRP because it's not something I've done in 20 years. The point being is we need a routing protocol to route between the subnets. Otherwise, if we don't have a path to it, we can't reach it. So there's that. So let's give you a little bit of look into some of the things that are going on via IP. So for whatever I did in EIGRP that wasn't right, let's just fix it. Config T, router, no router EIGRP1, no router EIGRP1. Router OSPF1, network 0.0.0.0.0.0 255.255.255.255 area 0. There's a reason we're gonna play with this a little bit. I want you to start seeing what's going on. Config T. No router EIGRP1. Router OSPF1. Network 0.0.0.0 255.255.255.255 area 0. Let's let this neighbor adjacency come up, and then let's look a little bit about some of the things that I told you which were going on in the network. So we're here. We're here. Let's make sure OSPF is coming up. Show IP OSPF neighbors. It usually takes a little bit to come up. Let's make sure, okay, we're still on 2A. 2A has to go to full. Once we get to full, we'll run a shortest path first calculation. Well, what's going to happen is we're going to get a syslog message. There you go. Adjacency changed. We went to loading to full. Now, what we do is show IP route. You'll be able to see we've got full routing. I'm going to teach you something, and I'm going to show you something which you should never do. So, again, I'm teaching you a little bit about Internet Protocol. So don't do this on a real production router or you will break the network. But it's pretty good for you to see what's going on. So if I do a debug IP packet, what I can realistically do is I can actually turn this router into a sniffer or a protocol analyzer. I'm going to do that. And what's going to happen is I'm going to let you see the messages that come across. Okay, so 192.0.0.2 destination 224.0.0.5. That's an OSPF hello. Here's another OSPF hello. We're looking over here. This is all OSPF communication with each other. OSPF, OSPF. Now, I'm going to generate some ICMP traffic, ping, and I'm going to do 2.2.2.2. Now, watch, as soon as I send this, we're going to see ICMP messages. Look. Now, look at this. These packets look a little different. We see an IP packet with a source address with a destination address of 2. You can see it. I'm going to do it again. Oof, you see that? Source, which is the reply, going back to here. So we have 192 talking to 222, and then you can see we have 222 responding back. That's the way this works. You talk to them, they talk back. I'll do it again. I'll ping across the link, 192.168.0.2. Watch, the destination address will be different. See it right there. 192.168.0.1 going to 192.168.0.2. Heck, while we're at it, let's get out of the debug. Let's add some more subnets to this device. Enable. Config T. Int. Loopback 1. IP. ADDR 3.3.3.3. 255.255.255.255. Area. Make it area 1. Oh, let's not do that. Let's not do that. Create another loopback. Let me do this. Let me exit this, exit this. No debug. It's going to drive us nuts. Oh, never mind. No debug IP. Okay, so we can shut that off. And now you can see we're not going through there. But let's do this. Let's add a couple more. Config T interface loopback 2 IP ADDR ADDR 4.4.4.4 255.255.255.255. No shut. Now going back to our router over here, what kind of routes are we going to see in the routing table? Look at that. 1, the 2, the 3.4. Can we reach it? Yes. Can we reach 3.3.3? We should be able to. We have a route to it. Can we reach 4? So we've got a route to it. Oh, we're at it. Now let's see if we want to see what's going on with OSPF neighbor relationships. Debug IP OSPF. One. Now, these devices send periodic messages to each other. So, what's that mean? Hello, are you there? Sending from one to this device. And it sends the hello to the multicast address 224. Guess what? Hello, are you there? Guess what's going to happen in a couple more seconds? Hello, are you there? You're going to see it. Anybody ever work with load balancers or DNS and hear of a health check where it says, hey, are you there? Are you there? Are you there? Are you there? So now let's have some fun with this. Config T interface B0/0. Remember, that's the link on the other end of the line. Now watch what happens. I'm going to shut it down. Shut down. Okay, what's going to happen? Are we going to be receiving any hellos from the other router? It sent a hello. Did it receive one? Didn't receive one. We sent a hello. Did it receive one? Sent another hello, but we didn't get one back. This doesn't look good. This doesn't look good. This doesn't look good. Now, while we're at it, another one. Now, let's look at the routing table over. Look at that. OSPF adjacency CHED. Neighbor 1.1. Neighbor is down. Dead timer expired. Okay, so now what kind of routes do we think we have in the routing table? Go to the other router. Do we have any routes to it? Show IP route. No routes. Why no routes? Why no routes? Because we unplugged the cable. We shut down a port. OSPF sent a hello. Are you there? Hello. Are you there? Hello. Are you there? Hello. Are you there? You must be dead. Goodbye. You're not there. Remove it. So watch what happens. Now I'll turn the port on. Interface G0/0. We'll have some fun with it. No shutdown. Now watch what happens. OSPF is going to start sending hellos. Line protocol went to up. Okay, we just sent a hello. Haven't gotten a response back yet. Adjacency change. We send a hello. Okay, we found somebody. Guess what? They sent us a hello. We received a hello. Okay, we sent a hello. This is looking good. Now we're full. We send a hello, they send a hello. We send a hello, they send a hello. Now, do we think we can reach all those subnets now? Let's look at the routing table. So, show IP route. We can reach it all. Ping 3.3.3.3. Ping 4.4.4.4. Big T interface G0/0 shut down. Watch, we're sending hellos, we're receiving hellos. It's gonna go, it's gonna go, it's gonna go. We sent a hello. Whoops, we didn't receive one. Not good. So we're gonna send another hello in 10 seconds. We'll wait 10 seconds to get a response back. No response. Okay, every 10 seconds, hello. There you go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello. Oh, no response. Dead. Okay. Line protocols down. OSPF neighbor adjacency is down. Do we have any routes? No. Wow, that's no good. We can't reach it. Why? Because the link is dead and OSPF misses 4 hellos. And it says, dead to me. Dead to me. Removed from the rotation. We need the network to work. Dead to me. So let's make the routing work. G0/0. No shutdown. Okay, we're having some fun with it. There you go. Can we run more than one routing protocol on a router? Yes, we can. We can run more than one routing protocol on a router. So we're going to be getting into a lot of concepts when we deal with multiple routing protocols on a router. So if a router has multiple routing protocols, the routers are going to have to determine which one. So let's walk through some show commands while we let that one debug because it's kind of fun. Some things to remember. Walk you through some show commands. So we have the show. IP interface is brief. You're going to be using this constantly. It's going to show you the IP addresses that are available. If we do a show protocols, we can see what's going on. We can do a show interface. Get lots of detail on that interface. So while we're at it, let's walk through some more Cisco commands for the day. Go through a little more of it. So, hey, maybe we'll have just a little bit of fun. So, well, config T. Well, let's do this. Let's do interface loopback 4. Let's do an IP address. We're at it, and let's call it 5.5.5.5. Okay, so we just added another subnet. Now, right now, that subnet's actually added to OSPF. Why is it added to OSPF? The reason that a subnet is added to OSPF is as follows. I used a command that said install everything into OSPF area 0, which we would never do. So let's do this. Let's stop the debug because it's driving me batty. No debug, IP, no debug, OSPF. Okay, so we shut off all the debugging that I turned on. Let's have a little more fun. Let's just add another routing protocol. So we'll do this. Config P router BGP 1, 2, 3, 4, 5. Now, while we're at it, let's put a network statement of 5.5.5.5 255.255.255.252. also create a summary of 5.0.0.0. Create a neighbor. Let's do 1.1.1.1. That's going to bring us into the EBGP multi-hop. Let's not do that. Let's do neighbor 192.168.0.1 remote AS. We picked this one 1, 2, 3, 4, right? 1, 2, 3, 4, 5. So we'll make that 5, 6, 7, 8, 9. Now we'll go over to this router. We'll do a config T. We'll do a router BGP 5, 6, 7, 8, 9. We'll do a network statement 1.1.1.1. We'll do a network 1.0.0.0. We'll do a neighbor 192.168.0.2 remote AS. 1, 2, 3 was 1, 2, 3, 4, 5, right? Yeah. Okay, so we just formed the BGP relationship with our organization. So now if we do a show IP route on this router, what do we see? You see right now our routes are still being learned via OSPF. Why? Why? It's not in the table because we're dealing with eBGP yet. And is the next hop reachable? If the next hop is reachable, yes. If it's not, then no. So that's what's going to determine whether we get there or not, is whether the route is in the routing table. We can't populate into BGP a route that's not in the routing table. Got routing in here. That's how we would configure an additional routing protocol. We're gonna spend a day doing that because I want that to be fun. But here's the key. What did we do and why did we do it? We did a couple of things for the following reasons. We came up with an IP addressing scheme. We showed you how you could summarize routes. We showed you how you could subnet routes. We showed you how to aggregate this. We showed you how to pop these questions in. So let's take some questions for the remainder of the day. And if there's any questions, I'd like to answer them. So Chris, let me go back to StreamYard, see if there's any questions that popped in while we were having some fun configuring these kinds of things. Sarah Ahmed, yeah, I think I'm going to have that the last thing we do today. I've been pushing you guys pretty hard. Tomorrow's a Friday, so we'll probably push it pretty strong. But I don't want to exhaust anybody. A lot of you guys are doing my Cloud Architect program plus this. Many of you guys and girls have full-time jobs. So today, yes. Cryptophene, I am so happy. Teaching networking can be a little dry from time to time. So I do anything I can. I try and sing, dance, do a little Jeopardy music. Here's the thing. I know what it was like when I took courses and it was hard to be there. So, I try real hard to make it as interesting as possible. Kenya, you can bring me with you anytime. I know you really well. You're about as sweet, nice, and smart as they come. Happy to go to work with you. Angelo, thank you so much. Here's the funny thing. I've been doing system design so long that I don't even do system configuration because that's what happens when you become an architect. So getting my hands so dirty like this, doing a little bit of engineering, which I haven't done in a while, I think you can assume there'll be some engineering courses coming from us soon because this has been too much fun. These labs are interesting. I'm so thankful. I'm so happy to hear that, Twinkle. Mike, if I tell my kids don't do something, that's exactly going to be the first thing they do. I know, but I wanted you to see the sniffer potential to actually look through the data that's going through the network. And at the same time, I also didn't want you to actually do that on a real network. Now, Eva Doikis, troubleshooting with Cindy is a magical experience because normally speaking, when you get troubleshooting, you can look at a routing table. It's real simple. But when you got a cute kitten that basically chews just enough through an Ethernet cable to cause electrical signaling problems, but not the line to go down, wow, we got some interesting troubleshooting. And when Cindy likes to lick her paws and with her wet paws, push the power buttons on my computer, that really doesn't do a lot of good either. And of course, fur all over the vents of my computers and routers and switches is also not very helpful. But I can't imagine not having the little baby girl with me. How should you resolve subnets with overlapping IPs? That is what network address translation is for, until you can readdress it. And that's why I say to people, and learn that. And that is not just going to the internet. Company A buys company B, woohoo! And they use not between them. Chris, you can bring in the next one. Came in just now, but you're glad to be here. Anthony, we're thrilled to have you here. Come back, watch the replay. Danka, you're welcome so much. I'm thrilled to speak with you. Like I said, I want to train the next generation of the world's best technology leaders. Chibuki, can VRP or virtual router redundancy protocol be implemented between the data center and the cloud? You could, but what you would probably do would be as follows. You would typically set up a private line to the cloud and another private link to the cloud. And then what you would do is you would do multi-group VRP. What I mean by that, you would send one set of subnets on one link and one set of subnets on another link. But realistically speaking, VRP is probably not where we need to go to. We're going to be using BGP and IBGP between them, and we're going to be basically creating some routes. So we might use VRRP or virtual router redundancy protocol, which we'll talk about on the connections to the cloud. But really, it's BGP that we're going to be using, much heavier. Ruben, thank you so much. And William Byrne, who's an extremely experienced technology instructor, really experienced. We're honored to have him here. He taught at Alcatel-Lucent for forever. Yes, trying to do this live is always brave. You never know what the heck's going to happen because tech doesn't always work the way it's supposed to be. Our assignments are really challenging. Yeah, there's nothing simple about cloud computing or networking, so I have to give you what you need to get you all cloud hired. Yep, agree completely. John, it's always wonderful having you here. So thrilled you're here. Cedre, thank you so much. I enjoyed being on the web podcast manager. I loved it. So thank you so much. Actually, Chris, from my team, if you can pop a link to that podcast, it's a pretty big podcast of networking professionals. We were just there today. We were talking about how to create high availability, high performance networks, specifically with regards to multi-cloud. So it should be very applicable for all of you guys. So Chris from my team, if you can pop a link to that, or better yet, pop the link to the LinkedIn post today so everybody could see it. I'd love everybody to see that. Oh, it's good to see you, MJ. You're more than welcome. Are we going to discuss VBNs, Aqua? Absolutely. Absolutely. Aqua is a wonderful guy. He's a friend. He does a lot of work helping with the War Fund crowd, and Aqua's got a great networking background. Aqua, definitely. I'm honored and happy to see you here today. I would have loved to have met you 10 years ago. You're more than welcome, Sarah Ahmed. Do you have any assignments you can practice on? Honestly, John, I think you should just go through the class this week. What I think you should do after this week is I think you should read this week and next week. I really recommend you read that book from William Odom from Cisco. It is an effective, wonderful, miraculous book. I think the two books together from Cisco Press are about $50. Remember, Cisco wrote the book for a Cisco exam, and it's from Vernal Odom. His CCNA number is like 1064 or something like that. So that is the official curriculum. And I have gotten more people hired from literally tutoring people straight out of that book. So I love that book. Strongly recommend it. I think that's what's really going to help you. And then after the course, if you want to do some kinds of labs, I'll make some recommendations in the end of the class. Sharon, you're more than welcome. Thank you so much. That's what I'm so glad you're bringing people. What I try and do is I try to make it as real as possible based upon real experience. Angela, thank you so much. I'm so thrilled. Clint Stevens, buy the two as a bundle. It's like $50. And I'm telling you, that is a bundle that you should have. Like, I get paid nothing by recommending our Cisco's products. I earn nothing. I'm not an affiliate, but I want you all to have the best careers. And you know who I always recommend? The manufacturer's documentation, the official stuff. It's good stuff. And Chris, you can bring in the next one.
I want to reiterate about buying this. It's not just the book; it's all kinds of resources that Cisco provides. You know, you might not be able to see it, but literally all these resources that you get access to. You get access to all their practice stuff, all their virtualization stuff, all their everything. And since they're the ones that make the exam, that's why we strongly recommend going there. And we share the link to their page for the certification so that you see all the resources available. And not just the book, because it may seem like there's a lot, but it's just one purchase that comes with all this stuff. So I just wanted to pop in to make sure everyone was aware of that.
And you can see that I've been a network architect for 25 years. We still have the official materials for us because we always go with official materials.
Yep. So I'll pop back off now.
No, Chris, I think you're great. Thank you for showing that book. I'm thrilled you did. That's my recommendation. Can I get everybody, if you had a good time, to say hashtag CCNA and hashtag Cloud Architect? My two favorite words. Yeah, Sharon, that's my whole goal. I want to make it real, get rid of all the marketing speak, all the fluff, and make it that you guys are all experts. Brian, I think that's great. I'm so thankful Chris showed that. We have class tomorrow. Absolutely. 12 to 3 tomorrow, 12 to 3:30, something like that.
And just to clarify, in case any of our students for the Cloud Architect Career Development Program are seeing this, we don't have that class tomorrow. We have this class on YouTube tomorrow.
Yes, because many of my students had said, Mike, we love you, but you give us a video to watch each day, 10 posts to read each day, or 500 hours of course. If you're going to bombard us with all this networking stuff, can we please have off Friday? So that's why our students are off tomorrow. Cloud Heart, exactly, Aqua. CCNA. Oh, so thrilled to see you. Love it. Absolutely love it. Gabriel, nice to see you. Sharply dressed there. Mick, good to see you. Sharon, Cloud Architect. I love it. So please tell friends to watch this free training. Hand of God, you always have the nicest things to say. Salutations to you, Mr. Mike. You are a wonderful thing. I appreciate your presence on Earth. I wish you all the best. I have to say, when I see your messages, they are so warm and sweet, and I appreciate them more than you know.
Yeah, it's almost as good as rubbing my cat's belly. You know,
yeah, I appreciate it that much. Mark Hema, CCNA. Anthony, CCNA. I'd love to speak to you, Anthony. Chibuki, CCNA. Abigail Marks, yes. CCNA, Cloud Architect, and CAD hired. Carlito's Way, CCNA. Robert Welch, Cloud hired, yes. Danica, Cloud hired, yes. Aguilo or Angelo, CCNA, yes.
So I see where MJ said that they got the book off of Amazon. That is a great place. One thing to keep an eye out if you buy it used, some of the resources may not be available because they're limited to specific uses. So just keep an eye out on that when you're doing those.
But no matter what, use, new, get it. This is some good information. Mark Mahal.
Yeah, the contents of the book are still the same.
I love that. Sean Ford, I see you more than my wife. You know, the sad reality is I see Chris more than my wife.
I'm not going to comment because my wife is occasionally on YouTube. So,
well, my wife is at the hospital, is taking really great care of her patients half the time, so that's the reason why. Mr. Gaze. So yes, Amazon has them used. It's a great environment. You may, well, thank you, 7 Series Beamer. You know, I got to say, I just love working with the community, whether I was teaching engineers at Cisco, Riverstone, WorldCom, Comcast. I just like teaching. I'm William. So happy to have you here.
Do we have an idea of what might be on the agenda tomorrow? I know
I think we do. Let me go through and see what's on the plan schedule for tomorrow. Okay, so I know what we actually have in here. So we're going to start configuring some sample networking and some routing. Then we're going to be looking at ARP tables. We'll be doing with some static routes. We'll be pumping at host routes versus traditional static routes. Then we'll deal with a whole lot more stuff. And then we'll deal with some overlapping routes. And then after that, we'll do some LAN routing, and we'll do some VLAN tagging and some VLAN trunking. We'll be talking about 802.1q tags, etc. And then after that, what I would be doing, we'll be dealing with some switched virtual interfaces and some routing. That might be a little bit fun. Be doing some troubleshooting of routing, which is going to be kind of fun. And might even do some ether channel kind of stuff. So it's going to be a really fun day. Lots of tech. Starting to get more into the routing concepts, which is where everything comes fun. So we've had to hit the heavy stuff, the hard stuff, the ugly stuff, the spanning tree, the rapid spanning tree, the subnetting. Now we get to the fun. So have a wonderful night, all of you. It's been an honor and a privilege to know you, to see you, to work with you. Tell others to watch it. If you haven't hit the like, comment, or subscribe, please do so. Please tell your friends. And guess what? If you've not gotten a copy of our free AWS Certified Solution Architect Professional book, please download it. The link is in the description below. Got to know the cloud in today's world. And whether you're a network architect like me, a cloud architect like me, or either way, you still have to know the cloud. So see you all tomorrow. Have a wonderful night. Have a great night. And seriously, get some rest so we can come back tomorrow and have a party.